This is the most popular topic in the data engineering interviews, and I am talking about Delta Lake. And this 3 hours long Delta Lake 4.0 full course will cover all the concepts and hands-on in the form of dedicated chapters so that you can easily understand everything and can take notes. There are so many upgrades and new additions in the world of Delta Lake that has been recently introduced. So that is why I have created this another in detail full course for Delta Lake so that I can cover all the concepts including updates as well, which are strongly focused on the 2025 industry standard. I have literally collected so many resources such as physical books, official documentation, official courses, just to make this Delta Lake 4.0 course so that you do not need to pay to anyone else. But just drop a lovely comment and yes, let's get started with this amazing masterpiece.
What's up, my da fam? Happy Sunday. And this Sunday, we're gonna talk about Delta Lake from zero to pro. I know you can have some questions. Hey, we already have covered Delta Lake in our previous video. I think I made it like many months back, but do you know what? There are so many updates after that particular, you can say, launch of the video. So we have to cover all the new upgrades as well. So what I thought like, let's recreate this masterpiece because Delta Lake is becoming more and more popular with the course of time. And if you do not know about Delta Lake, bro, you should know about Delta Lake. If you are a data engineer, or if you want to become a data engineer, or if you want to, let's say, do some wonders in this particular domain, which is data engineering. So what are you doing, bro? What are you doing? Just learn Delta Lake. So you will be saying, hey, what are the best resources? So let me just tell you my story. Okay. I rarely share my stories. So let me just share this time. So basically, when I was learning Delta Lake, I had to refer so many resources. First of all, I heard the word, what is Delta Lake? I was like, what is Delta Lake? We have Data Lake. We have Lake House. Now, what is this Delta Lake? So that curiosity actually pushed me to just look for the resources, but actually I didn't find any good resources. It is what it is, because I'm not blaming anyone, but it is what it is. So then I purchased a book. It's called, I think, Delta Lake Up and Running. It's a great book. I just started reading that book. I was doing hands-on. I was just using Delta Lake in my day-to-day activities. Then the moment I finished that book, I got to know that half of the content is updated. I was like, what? Are you serious? Then I got to know that, hey, this field is evolving. This means like specifically this open table format, okay, where we have like so many different open table formats, Delta Lake, Apache Hudi, and your Apache Iceberg. The most popular one is Delta Lake, okay, because it goes hand in hand with your Azure tech stack plus Databricks, and you know the demand of Azure and Databricks. So if you want to become a data engineer, if you are just trying to sit for the interviews, anything, you cannot afford to skip this topic, or you will say, I know just a little bit of Delta Lake and I'm fine. No, you are not fine. You have to master this topic because you cannot build solutions without Delta Lake. If you want to build solutions, you have to use Delta Lake and you have to master it. Okay. So what I thought, let's cover all the topics. That means like all the topics. It will just make you a pro Delta Lake developer. And I am expecting from you that you do not have any kind of knowledge. You do not have any kind of, you can say, prior experience. Everything will be starting from zero. So do not worry. Even if you do not know about Delta Lake, that thing will also be covered. So do not need to worry. Make sense? So in this particular video, we're going to cover Delta Lake. Yes, we have already recorded one video for Delta Lake, but we have so many upgrades. So we are actually just, you can say, creating another masterpiece for Delta Lake, which will be covering all the upgrades. So just for your information, we have Delta Lake 4.0 for now. So this video will be valid till 4.0, and 4.0 is compatible with all the latest Databricks changes and all those changes, and obviously with your Apache Spark 4.0 as well. So this is your golden opportunity to master it, because you know what, let me just tell you, because I know the dynamics of the industry. Let me just tell you, everyone wants to learn Azure Data Factory. Everyone wants to learn Databricks. Everyone wants to learn PySpark, Spark, all these things, but no one actually is talking about Delta Lake. And you know what? When they learn those tools and when they actually sit in the interviews, or when they actually get assigned, let's say someone is working in the consultancy firm and they are assigned to a project where they're just building the real world projects, right? Like data warehouses or anything. When they actually see the Delta Lake, they actually realize at that moment that this is really, really important. So you do not need to do that mistake. You have to master Delta Lake before sitting in the interviews. Or you can say, if you are already assigned the projects related to data engineering, and if you are thinking, hey, I do not need to cover Delta Lake, bro, just think again. You need to master Delta Lake, because without Delta Lake, you cannot build any solution, anything. Okay. So do not be mistaken. I know not everyone is talking about Delta Lake. I think I am the only one who is stressing a lot on these topics because I genuinely do care about you. Okay. So just listen to my words, trust me, and let's get started with this masterpiece. And let's actually start from the scratch. What is Delta Lake? Let's see. So in order to understand Delta Lake, we have to go back in time. Okay. So let's go back in 1980s when I was, I think, 20 years old. Minus 20 years old. Okay. So the thing is, when we were newly introduced to the concept of data storage, and I'm talking about data storage for data engineers. I'm not talking about any databases or anything, okay? We are data engineers. We will just talk about data engineering stuff. No anything like, we will not be talking about anything else. So when we were just storing data, who we? Data engineers. Then we were introduced to the concept of data warehousing, okay? Data warehousing. And this concept was actually provided by Kimball. Ralph Kimball, I guess the full name is. Yeah. So this concept was data warehouse. So this concept was actually provided by Kimball, where he said, hey, obviously you want to store the data. We said yes. So he said, hey, you can simply store your data in the form of dimensional data model. What is dimensional data model? It is nothing but, you can say, fact and dimension tables, where you store the data in the form of facts and dimensions. One fact table and multiple dimension tables. Make sense? Make sense? This is just a fundamental thing, bro. Facts and dimensions. Fact table will take care of your all the numeric columns, and dimension tables will take care of all the contextual data, which will provide, you can say, some kind of context to your fact table, right? So this concept was actually given by Ralph Kimball in 1980s. Then where we were actually storing this data? We were storing this data in the SQL database. Yes, in the SQL tables. Make sense? Everything was fine. Everything was fine because data was stored efficiently. We were able to apply some amazing, or you can say necessary operations such as ACID, which is atomicity, consistency, isolation, durability. Okay, ACID properties, which takes care of your, let's say, if one record is like being written, no other record can be written to the same thing. If one record is like cancelled, then there will be no transaction, all those blah blah things. Okay, so ACID properties are like the fundamental things if you are in the data domain. So ACID properties were there, commit rollback facilities were there, everything was there. So everything was actually smoothly running. Makes sense. And this dimensional data model was actually performed with all the modern, you can say, reporting, BI tools as well with the course of time. Okay. And at that time, obviously, there were not many reporting tools, but yeah, whatever tools we had, it was performant enough. Then with the course of time, our data started growing. Okay. Our data started growing, and this technique was actually failing. Why? Because you cannot scale databases easily. Or if you can scale the databases are actually not designed in such a way that can handle large loads, right? And obviously they are expensive. If you want to just scale up your database, or you can say SQL table, you have to just spend a lot of money as compared to, you can say, your file system. What did I use? File system, or you can say files. Files are always cheaper than your traditional database or data tables. That's where we got the concept of data lake. So around 1990s or maybe in the early 2000s, we got the concept called data lakes. So we said, hey, you can simply store your data in the form of, you can say, not in the form of data lake, but yeah, in the data lake. Okay. Why? Because this approach, this data warehouse with SQL database approach actually gave birth to three major problems, and we also call it as 3 V's. And just for information, now we have 6 to 7 to 8 to 9 V's, but these were like initial 3 V's, which is called velocity, variety, and veracity, I guess. So these 3 V's, what is velocity? So data was actually being generated with a, you can say, rapid rate, and we were not able to handle that speed. Second thing, variety. We were receiving not only structured data, we were receiving unstructured data, we were receiving semi-structured data, images, files, so many things. So variety was like growing. Then veracity, we were not able to trust the data. Make sense? Trust means like you cannot say, hey, you have processed, because obviously you cannot process the semi-structured data, you cannot process the you can say unstructured data. So how you can just trust the data is accurate, or the information that you're providing about the data is accurate? No, right? So that's where we have concept called data lakes. Let's try to understand data lakes. What's there with the data lakes? So with the data lakes, we simply store our data, whatever data we have. If we have structured, if we have, let's say, semi-structured, if we have unstructured, you can simply dump your data and it actually solve the problem of 3 V's. Why? Because whatever volume we can get, okay, we can easily store that in the data lake. Makes sense. Any variety, you can see all the varieties are here. Veracity, because obviously you can now trust the data, because now it can easily be stored in the data lakes and you can just take decisions on top of it. Everything was fine. But this approach actually benefited data scientists a lot, because they just wanted to use the data sitting in the data lakes. But when data analysts were trying to use this data, they were facing some problems, or not just like normal problems, you can say performance problems, performance issues. Their reports were taking longer to refresh, and they were not able to build, you can say, relationships easily between the tables, and there were like so many other things as well. Then what they tried to do, what did they try to do? They said, hey, we will simply put our data, let's say this is the data, okay, this is like semi-structured data. They said we will simply be using data lakes to dump this data. Make sense? So this is our data lake, and this will be used by, let's say, data scientist or whatever person wants to use this data from the data lake. Then they said this same data will go to the database as well, because data analysts need to use this data to build the reports. So we were using 2 times ETL method, one for data lakes and second time for database. And people were like, bro, are you serious? Do you have a lot of time? So then finally in the, I think 2010s, we got the concept called lakehouse. Now within this lakehouse concept, or you can say 2020s, not 10s, like obviously after like around 2015, after 2015, I'm so sure. You can just check the dates, okay? By the way, there's no official date. So we got the concept of lakehouse. If you observe this word carefully, you will find that this word is made up of 2 words, data lake and data warehouse. That means we can leverage the best of both the worlds. We will simply say, hey, you have your data sitting in the data lake. That's for sure. You will say yes. Then you will say, hey, you want to build a data warehouse because you want high performance with your reports and all the things. You will say yes. Then lakehouse says, I will do both of the tasks. And now you'll be like, how? Because this is different. Yes. That's where the concept of, you can say, open table format comes into the picture. Open table format. And I will not use the word open table format. I will use Delta Lake because we are talking about Delta Lake. So Delta Lake is one of the open table formats that we have available, and Delta Lake is the most mature open table format, and it is the one that you should also focus to learn in 2025. And trust me, when you will actually see its power, you will actually feel, okay, this is really powerful. Okay. And Delta Lake can be easily connected with your Apache Iceberg, Apache Hoodie. So it has a term called uniform, and we will be talking about a lot of things in this. So I'm just giving you some hints. Delta Lake should be your priority. Okay. Then let's talk about Delta Lake. So what it does, Delta Lake is the backbone of Lakehouse. So your question is valid, how we can just merge both the areas, data lake and data warehouse. How? That doesn't make any sense, right? But Lakehouse says it makes sense to me. How? With the help of Delta Lake. So Delta Lake is the backbone of Lakehouse. Without Delta Lake, there cannot be any Lakehouse. No. Make sense? Now I hope you got little understanding of Delta Lake. Now let's focus on what is Delta Lake, what problems Delta Lake has solved, and how it is the best choice for today's data engineering. Let's see. So let's talk about why Delta Lake. Okay. So basically, traditional data lakes in which we were just saving, or you can say storing our data in the form of Parquet, CSV, by the Parquet. Someone was saying like, it's not Parquet, it's Parquet. It's Parquet or Parquet, it's up to you. I call it as Parquet. So if you have your data in the form of Parquet or CSV or Parquet on cloud storage, we had some limitations. What were those limitations? First of all, point of focus, no asset transactions. That means data can become corrupt if two jobs write at once. Okay. There's no like isolation, there's no atomicity, there's no durability, no consistency, nothing. Hard to handle schema changes exactly with the course of, you can say, with the rise in big data. Schema changes is like your bread and butter. You cannot live without that, right? Then no easy way to track changes or roll back to an earlier version. This is the thing that I was talking about, right? All these things are only available, or I can say were available, only available with the SQL databases. But all these things are available with Delta Lake as well now. That is why it is the game changing thing. We have asset transactions, we have schema enforcement and evolution, we have time travel, we have unified batch and streaming, both the capabilities applied on top of it. And we have data lineage as well. Data lineage, yes, it's called data versioning in Delta Lake, everything. I know you are really excited to see all these things in practical. So I will just show you each and everything. Don't need to worry. Then let's talk about Delta Lake architecture. What is the architecture of Delta Lake? It is very simple. So far we are saying Delta. What is Delta Lake architecture? How does it look like? Because you can be confused between Delta Lake and Delta format, right? And let me just tell you, both are same thing. Really? Yeah. If you say Delta Lake, it is fine. If you say Delta format, it is fine. It's up to you. Okay. Some people say Delta Lake, some people say Delta format. I say both the things whenever I just do like. So both are same things. Let's start with Delta format. Why? You will understand better. Okay. Otherwise you will relate Delta Lake with your data lake. Delta Lake actually does not like hold any data. Okay. It is just a kind of logical layer. Make sense? So let me just tell you how everything happens, because it is not a, you can say, magic. Everything has a logic. Yes, there are some magical things in the world, but yeah, those are real magic, not this thing. This is just a logic. So now let's say you have your data in the data lake. Okay. Let's create a box here. Like, let's say this is your data lake. Make sense? This is your data lake. Because one thing to note, every data will reside in the data lake itself, and we will add the data warehousing capabilities on top of it, and that's why it will become Lakehouse. Okay, let's see what happened. Let's say you have some files, and these files are in the form of Parquet, and this has an extension called .parquet, right? This file is also of the Parquet format. Yes, this file is also of the Parquet format. So far, this is like your normal data lake in which you have the files in the form of Parquet, right? Makes sense. Now, if I say I want to convert this file into Delta format, or I want to save this data into the Delta format, or you can say I want to save this data in the Delta lake. Okay, what will happen? So everything will be same. This Parquet file will be here. This Parquet file will be here. This Parquet file will be here. Okay. Ansh Lamba, I said save it in the Delta format. So I am expecting something like this, dot Delta. So the answer is you do not get something called as dot Delta. Delta format will also have this format called dot Parquet. What? So how it is called as Delta Lake or Delta format? So let me just tell you how and why. When you say I want to convert this data into Delta format, or you want to save your data in the Delta format, so data, the original data files will be in the Parquet format, but along with that, you will get something called as Delta log. Okay, you will get something called as Delta log. What is this Delta log? And if we get Delta log, that means it is a Delta lake or it is a Delta format. Yes. What's so special inside this box? This is the backbone of your Delta format. This is the root of Delta format, and this is everything. Why? Because it takes care of all the transactions. It takes care of all the transactions, everything. Let's say you added this data. It will save this information in the Delta lake, in this Delta log. If you, let's say, update this data, it will save this information in the Delta log. If you say, hey, I will just, let's say delete this data, it will save this information in the Delta log. This way it enables asset properties. Okay, it enables asset properties, and on top of it, it enables data versioning. All those things that you are just comparing it with the SQL Server, it will enable everything with the help of this Delta log, because it keeps a track of everything. It keeps the track of every single transaction. Make sense? So this is the Delta log. So let's say you want to create your data, or let's say you want to just save your data in the Delta format. Then you just need to say, hey, I want to just save my data in the Delta format, and this will create a Delta log for you. Okay. And a very good example can be a Delta table. Delta table means you want to create a table and the underlying data will be saved in the form of Delta, right? Very good. So do not get confused. Delta Lake is not a storage solution. Delta Lake is a kind of, you can say, logical layer. Yes, the names are very similar, Data Lake and Delta Lake. That's why I prefer the beginners to use Delta format. Do not use the word Delta Lake. You will be confused. Okay. Always use Delta format, because when you say Delta format, you know that you are talking about the format of the data. You are not talking about the storage solution itself. Storage solution is still Data Lake. If you are from Azure background, it will be ADLS Gen 2. If you are coming from AWS, it will be S3 bucket. If you are coming from Google GCP, it will be Google Cloud Storage. So Data Lake is Data Lake. Okay. Within that, you create Delta format. I hope this was enough to provide you some ground level knowledge. Okay. Now we believe in learning by doing it. Okay. So now we're going to just see, and let's actually gain the hands-on by actually building some Delta tables and performing all those things. So how we can just work with Delta tables, because obviously we'll be just using PySpark and so many things. So the good thing is now we will be using Databricks. Databricks, you'll be saying, hey Ansh, how to set up cloud account? I cannot create cloud account, blah, 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 blah. So the good thing is Databricks has recently launched something called as Databricks Free Edition. And that Databricks Free Edition is like so good. Why? Because you do not need any kind of cloud integration. You do not need any kind of credit card. You do not need any kind of business email. You just need you. That's it. And you will be getting free Databricks edition. Databricks Community Edition is also there, but now it will be gone very soon. people say, hey, what is the difference between two and how we can just learn Databricks free edition? So there's no difference between two. The thing is, Databricks free edition is like much more than community edition. Databricks free edition is like the production ready Databricks workspace, which has all the features enabled. Whereas in the case of community edition, we just have like very little features. So it's a good thing for you, for all my learners, for all my lovely data family members. So let's actually get started with the, you can say, practical hands-on, because now you have a base ready and you have some conceptual knowledge ready, because when now you will be seeing at the things, you will relate it. Otherwise you would feel lost. Okay. So now let's get started with our free Databricks edition, Databricks free edition, and let's create our first Databricks free edition. If you have not created, let's create it. Free edition. You simply need to go on Google or any browser, simply search Databricks free edition. Okay. And then just click on the very first link, any link that you can see, and it can directly take you to this page. Sometime it does not. So scroll down, let's say you simply click on this button. Okay. And you see this page. So in that scenario, everything is same. You simply need to click on try Databricks. Okay. Now this is the page. Now do not be in a hurry. Do not click on this particular button, which is continue with the express setup, because this is also one of the free trials available, but this is not actually purely free, because you have some credits. Once they are exhausted, you have to pay for the services. If you want to leverage everything for free, you have to click here, looking for Databricks free edition, click here. So you need to simply click here, and do not worry about business email, student email, any email. Just put your normal Gmail account and that's it. Then click on continue and you will land on the login page. Okay. Let's say you have created your account. Okay. Now, obviously you'll be landing on the home page as well of Databricks, but what if you want to log in again next day? Where is the link? So you simply can go on the same page, click on try Databricks, and this time there's another link just below to that one, and it is saying already have an account, login. So if you have created your account, if you want to reuse it, click on login, and this time you have to put your account that you have created for your Databricks workspace. Okay, perfect. So this is all about your Databricks free account, and once you do all these steps, you will actually land something like this. So this is my Databricks free edition. Okay, and obviously we will be learning Delta Lake in detail, so we do not need to worry anything about Databricks. But yes, I'll be just showing you some necessary things which are required basically for the environment setup. Okay, makes sense. So let's see what do we have in this particular Databricks workspace and how we can set up our environment for Delta Lake. So let's actually get started with our environment. Basically, we do not need much stuff to get started with the Databricks free edition. Why? Because we have everything that we need. Yes, we'll be creating a lot of new stuff that was not available in Databricks community edition, but that will be the part of this course. So I do not expect you know anything in this Databricks, so do not need to worry about that. So before beginning anything, I will simply go to catalog just to show you what do we have. Okay. So within this Databricks, oops, let me hide my personal stuff. So first of all, let me just clean this one because I do not need this. Yeah. So in this particular catalog, you should see only one catalog. Let's say workspace, because this is the catalog that you get by default. Okay. So within this, we will be creating a new catalog for this particular, you can say, course. Okay. Delta Lake. So in order to do that, you simply need to click on this plus button. Catalog is basically, you can say, it is obviously a Unity catalog. And do not worry, we are just focusing on Delta Lake because Delta Lake is an open source framework. Yes, it goes very well with Databricks and Azure, and we are just using Databricks as a platform to practice Delta Lake. Okay, so we are not covering Databricks, but yes, some dependent, you can say, components will be covered, such as volumes and all those things. So let's first of all create a catalog. So how you can just create a catalog? Click on plus new button and click on create a catalog. So here you need to pick a unique name. Okay, so I will simply say Delta Lake Ansh. Okay, in your case you can just pick, let's say, Delta Lake XYZ, whatever your name is. Okay, click on create and it will simply create a catalog for me. Catalog created. If you will pick a name that is already taken, that will throw an error. So you can just try renaming it and you can just pick any unique name. Okay. Then click on configure catalog and just say next, and then just click on save. Perfect. So our catalog is created, and by default we get two schemas. So we will quickly, or I think we do not need any kind of schema. We will simply work with default schema. That is fine. So within this default schema, we will be working our, we will be, you can say, building our all the notebooks and everything. Okay. So let's simply go to workspace. Okay. And let's create a folder first of all, because we need to just manage this folder for our all the things. I will name it as Delta Lake. Perfect. So this is my folder called Delta Lake. Okay. And I can even, let's say, rename it Delta Lake 4.0. And don't worry, I will just provide all the notebook, whatever we'll be building here, and like all the notebooks. So just enjoy, do not worry. Okay. So just click on this create button, and I forgot to mention, just hit the subscribe button right now. What are you waiting for, man? I'm just trying my best to keep you updated, to make you an outlier in the crowd so that you can just perform well in your career. You can just grow in your, you can say, life. So just help me a little bit. Just hit the subscribe button, drop a lovely comment. Okay. Just share this video with your friends so that you can help more and more people. And yeah, just do those things, right? You are a human. Just do good things in your life. So just click on this create button and let's create our first notebook. So when you click on this button, you will just see this kind of UI, which is just a notebook. And I expect that you would have worked with notebooks in the past. It is very much similar to your Jupyter notebooks, because notebook is just a notebook in which you divide your code in cells. That's it. Okay. So obviously I need more space. As you know, I will click on this 3 lines and this is my space. But yeah, I need a little bit less space. So I will simply click on this catalog button. So basically this is the area, or you can say this is the UI that you should also use, right? So now, first of all, first thing, being a developer, this is the best practice just to rename your notebook. I will simply say first and Delta Lake. Okay. Delta Lake. Perfect. Then you can simply attach your notebook to the cluster. So now you will say, hey, where is our cluster? Because whatever compute we use within the Databricks, we need to attach a cluster to it, right? It can be all-purpose cluster, it can be job cluster, it can be anything. But the best thing is Databricks Free Edition provides you something called as serverless compute. So basically serverless compute are managed by Databricks itself. You do not need to manage anything, and it will not be even created in your cloud account. So it will be purely, you can say, managed by Databricks, everything like infrastructure, scaling, everything. So that is the best thing. Okay. And by default, when we create Databricks Free Edition, we get 2 things. One is serverless compute for your PySpark, and second is serverless SQL warehouse. So they are like basically 2 different kinds of compute. You can say all purpose compute and SQL warehouse. Okay. These are 2 different kinds of compute. And in both the cases, we get serverless option by Databricks. So that is the best thing. Okay. Makes sense? Very good. Simply click on connect and you will see serverless by default, and it will be up and running in just a few seconds. So now you can see it is up and running. So first of all, we should learn how to create a table. That should be your first question. How we can create a delta table? Because we know the concept called lakehouse, in which we create the table. Okay, let's say this is your table, but this table is just the table. The underlying data is actually residing in the data lake. So now you will say, Ansh, Lamba, we know about Databricks. We can register a table here, but where our data will go? Where is our data lake? Because this is just the Databricks Free Edition, right? So the answer is data for Databricks Free Edition will go to the default storage location. Default storage location. And now where is that? Now where is default storage location? It is in the AWS account. Okay. You do not have any kind of AWS account, don't worry. Databricks Free Edition has, you can say, associated an AWS account to it. So you do not need to worry about that. Whatever data you will be writing here, it will simply go to the default storage account, which is linked to your Databricks Free Edition automatically. Make sense? So you do not need to worry about data. But yes, being a good developer, that was a good question, because obviously we just registered tables, or you can say metadata, in the Databricks. Actual data resides outside of Databricks. Okay. Yes. So let's talk about how we can create the table. Okay. And don't worry, we're gonna just refer the documentation as well, so that you will also be familiar with the documentation of, like, official documentation of Delta Lake, which is an open source framework. Okay. So first of all, let me just type something like this. So I will be just keeping this notebook neat and clean so that you can also refer it. Okay, just for you. See, I'm so possessive for you. So I will simply say create delta table. Okay, create delta table. Perfect. And let's keep the heading 1. Perfect. So now I will add one more heading, and I will simply say h3 bold using SQL API. So basically we have two APIs, SQL API and Python API. I will just show you both the ways. Basically not the Python API, Delta API itself. Okay. So if you want to use SQL API, that is the best and the recommended approach, because it goes exactly same as you use in your day-to-day SQL workloads. I will simply say create table. Okay. So now I want to register this table, right? So I will register this table under this catalog, which is called Delta Lake Ansh dot schema. Schema will be default. Okay. Then I will say table name. So this table, let's say our first table. Make sense? This is our first table. And within this, we want to say, hey, ID will be integer. Let's say salary will be integer, and email will be, let's say, string, or let's say just 2 columns. Nothing fancy. Then we need to say using delta, because we want to create a delta table. Now in the latest upgrades, we do not need to mention using delta, because by default Databricks creates the delta table for us. It's your choice if you want to mention. It's good because it is good for the readability, but I think it makes sense now. When it was really new, I also used to write using delta because it promotes readability, but now it is very much obvious and everyone knows, like, okay, if this is the table, it will be a delta table. Okay, perfect. So this is our code, and if I just run this, it will create a delta table for me. So it will take, I think, so as you can see that it is still running. So in the initial execution, it takes a little bit longer, that's it, but after that it will be very smooth. Okay, so this is done. I can confirm it. Let's say I want to see the results in the default schema. So this is my table. See, wow, that's how you can create a delta table. Now you will say, Ansh, Lamba, this is exactly same. Exactly. This is the power of SQL API. Now let's talk about Delta API. Why Delta API? If SQL API is the best, see, it depends upon the developer which API the person wants, right? You should be able to work with both the APIs. Plus, we have introduced some, not me, like Delta Lake people. Okay, so they have introduced some amazing features which are only available and compatible with Delta API. So you should be aware of both the APIs. So let's say text and h3 and bold, and let's say using Delta API. So now in order to work with Delta API, let me just take you to the documentation page, and I'll simply say Delta Lake documentation. I will read the maybe this one. Yeah, this one is good. So within this, I will simply go to Apache Spark connector. Perfect. And quick start. Let's say this one. Perfect. So if I scroll down, so this is my API for Python, or you can say Delta API. I call it as Delta API. You can call it as Python API. So this is the code for Delta API. So when we say, let me just change the theme, man. Because see, use modern themes. So I'm also a fan of, by the way, dark theme, like light theme, but sometimes I prefer dark theme. So now it's like dark here. So let's use dark theme. Perfect. Oh, amazing. I really like this glowing effect. See, when I hover over this, it glows. And maybe you will be seeing different color palette because I'm using a different editor theme as well. You can click on view and go to editor theme. I'm using, I think, Atom 1 dark. It is active. Yeah, you can also pick any one if you want. This is the theme for your fonts, okay, not for like this background, just for your color palette and all. Perfect. So let's now talk about this. So if you just want to use Delta API, what is the advantage of it? Advantages, yes, we will talk about it, but for now let's talk about what is even the Delta API. So basically Delta API is again like open source class that we have, and if you just want to work directly with the Delta data. What is Delta data? So when you create a table, that makes sense, we can work directly with the table name, but sometimes we do not create table on top of our data. That means, let's say this is your data lake, okay, and these are your Parquet files, and within this you have one delta log, right? Now it's your choice if you want to register a table on top of it. If you can just register a table on top of it, it's fine. If not, then you can just use the Delta API. So Delta API is like even more powerful and even more flexible. I know these terms are like very, very complex for now, but hold on, okay? You need to go step by step. Why I'm using these terms? So that you will not be feeling lost. Now, in order to use Delta table, okay, you first of all need to import one library. It's called from delta.tables, import Delta table, okay? Perfect. You simply need to run this, then it will be gone, that red mark. So obviously we do not need to worry about anything like all these things. So we can simply remove it, and I will simply keep only one thing, which is table name and add column. So we define obviously the table name. Okay, makes sense. We define the table name. Perfect. So we simply say delta table dot create if not exist. So it will simply create the delta table. Then we need to simply pass the Spark variable, which is the Spark session. Then we define the table name like this, default dot something like this. Okay, and here I need to replace this with my whole catalog name. So it will be, let's say, delta lake Ansh dot default. Okay, then dot, let's say, delta API, first delta API. Make sense? Now we simply need to use add column, add column, add column. Simple. Let's say I want to use ID, then I want to use add column, and I will simply say salary. The same thing. And let's say integer. Make sense? When everything is good, you can simply say execute, and it will create a table for us, and it will be the same delta table but with a different API. Make sense? So this table is created. Very good. And you can simply refresh it, and you can simply confirm it. Let's say delta lake default. See, our both the tables are created. I will just show you something that this is a kind of delta table. How we can just confirm it? You can go to these three lines and click on catalog. If you just open your catalog, and if you open your schema and click on your table, you will see this details section, and just click on details. So here you will see storage location is default, that I just told you. Table is managed, because obviously we are creating managed tables here. Then it is a kind of delta table where you can see, let me just show you in the overview tab as well. Here, data source is delta. Make sense? So here you can also confirm like this is a delta table. Just a quick, you can say, overview of this interface. And then let's click on recents, and then just click on first table. Perfect. So this is our, oh, what did we open? Okay, let's go to workspace and click on Delta Lake 4.0 and then Delta Lake. Okay, perfect. So this is the way we create the tables. Make sense? Now you will say, Ansh, Lamba, in SQL, we use something called as constraints, which are very, very important, because when you create tables, you have to pass some constraints. Let's say a not null, let's say unique, all those constraints. So the answer is you can also pass constraints in these tables as well. Make sense? How you can just pass those constraints? If you want to use, let's say, your Delta API, so you can simply pass something like this, like property, and then if you just want to pass it here with the SQL API, that I prefer it because it is like straightforward and it's very, very simple. So I think it's here in the bottom. Constraints. Let me just search. Yeah, here it is, constraints. Perfect. Oops. Oh man. Oh man. So constraints. Perfect. So here you can actually see we can pass the constraints like this. Okay, makes sense. So it will simply say not null, like exact schema, exact format as well. Forget about schema, exact format as well, exact syntax. So you do not need to worry about anything. Okay. So let's say you want to simply write something like, let's say ID, and you know that this should not be null. You will simply say not null, something like this. Make sense? Make sense? Salary, you can say unique if you want, like anything. And obviously ID, like salary should not be unique, but I'm just telling you that you can just do all these things. Make sense? And if you just want to use anything with SQL API regarding constraints, you can go ahead with this particular, you can say documentation, which is check constraints. I don't think so it requires any kind of documentation because it is pretty much straightforward. Make sense? Okay, very good. So now let's talk about something very special, and it is new as well in the world of Delta, and it is not new in your traditional databases. What's that? It is none other than, let me just create a text column. So H1 bold, and it is called identity columns. And here in Delta we call them as like generated columns. And within this we have identity columns. So I will simply say H3 bold and identity columns. So let's say, what are first of all identity columns? So let's say you have a table. Okay, you have a table, and within this table you have so many columns. Okay, and now within all these columns, these values will be coming from the source automatically. Okay, now within this I have a column ID, and I will not pass the value with my data. I want to automatically generate the data for this column. Let's say this is the first record. Let's say this is the first record. I got some values here, blah, 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 blah. So I want to just simply add 1 here. Similarly for the second record, I will pass values, let's say blah, 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 blah. I want to generate 2. So this way I just define a kind of identity column, and it automatically pass the value for me. It is a new thing, and it is only available with the Delta Lake API, or you can say Delta API, and it's not available with the SQL API for now. Okay, let me just show you that as well. I love that particular thing because it was not available before. So if you go here, and if you just go a little down, and you will see something called as generated columns. Perfect. So it says this is the basically the first of all the syntax for the identity columns, and within the generated columns we are talking about you can say identity columns. So we need to just cover that only. Okay, so identity columns are here. So these are the 4 types of identity columns. We 90% of the time will be using just the first one, because it will automatically start your, you can say, counting, and it will be saying generated always as, this is a function name that we use, and then we write identity generator, and this is the exact function. Make sense? But sometimes you want to manipulate the values, start value, and you can say iterating value. For example, you do not want to start it from 1, you want to start it from, let's say, 10, and you do not want to you can say increment it by 1, you want to increment it by 2, so it will become 12, 14. So you can just control those things by passing 2 parameters, start equals to -1 and step equals to 1. By default this function will take 2 parameters, start equals to I think 1 or 0, I am not sure, I can just check, and I think it is 1, and step will also be 1. Make sense? So let's try to create this particular column, and you will actually see the magic of it. A very real use case, it can be, let's say you want to create a dimension keys in your target table. It can be anything, by the way, it can be anything. So this is all about the identity generator. You will say, hey Ansh, Lamba, what is this then? Generated by default as, so what is the difference between these two and the above two? So the difference is this will automatically generate the value. Okay, and you will not pass any kind of value to this particular column. But let's say sometimes you want to pass the value to this particular column. Wow. So you can pass it using this particular function called generated by default as equals to this. It is not recommended. Why? Because you need to manage this column, because you will be just syncing this column with the original value. Just tell you one thing. You will say, I want to generate this value automatically. That makes sense because it will generate 1, 2, 3, 4, 5. So it knows that the next record will take the value of 6. Makes sense? But tell me one thing. If you are passing some default value, let's say you are passing like this, 1, 2, 3, 6, 10. So how it knows that I want to pass the next value as 11? How? So here we just perform some kind of, you can say, syncing. And this is the formula of it. If you are a fan of mathematics, you can simply apply this. So again, that's why I said in the beginning, 90% of the time, you do not want to pass any default value, because that's why you are creating this column. You want it to automatically generate this. Make sense? Make sense? Very good. Let's actually try to create this table and let's see what happens. Let's see. So I will create a new column. Oh, sorry, new table basically. Or I can drop the above table as well. See this one, because I don't want to create multiple tables of any use. So let's drop this table first of all. So I can write the code here, drop table. And how we can just drop the table? Same SQL code, that's it. And if you just want to drop this table, you simply need to write drop table, and this is the table name. Okay, let's run this. Okay, this table is dropped. Okay, now I can just recreate this table. I will simply say delta table. Okay, dot create, and then dot create, I will simply pass the name of the table. Delta table. Okay, perfect. I need to copy this name. Perfect. So you can simply write something like this. Okay, this is my table name and this is my, you can say, column that I want to generate. I will obviously add 1 to 2 more columns. Dot add column. Let's say I want to add salary column. Okay, salary, and then I will simply say data type equals integer type, or you can say long, it's fine, integer type, and then let's execute. Or let's add one more column. Let's say dot add column name. Yeah, salary and name. Then that's it. So in total we have 3 columns, right? But we will pass the value for only 2 columns, and it will generate, or you can say create, that particular value for our ID column, which is this one, automatically. Let's rename it to ID call and let's run this. Let's see. Unexpected character line. Okay, I think we have a space here, so you simply need to remove it. Sometimes it messes up like this. So if you see this kind of stuff, you can simply remove the backslash and you can simply wrap the whole code in braces like this. Okay, just run like this. String object has no attribute. SC. What is SC? Oh, so here we also need to import these types because these types are missing. So you need to import these types as well. Yes, we need to import these libraries or these function, these types from PySpark.sql.functions. Import asterisk. Why functions? Because maybe we'll be using functions. So, but this is the one that we need to import specially for types. Okay. Now identity generator. Okay. Do we have a specific library for it? Identity generator. Let me just check. Yes, we have. We have to import it from the delta.tables because yes, because this is only available for your delta API. So that is why it is not available with anything else. So it is saying cannot import from delta.tables. Okay, import delta table and identity gen. So the reason is very simple. So basically this is just launched this particular function just few months back. So I think the cluster that we are using is not compatible with the latest one. So I have just tested it in my all-purpose compute using Databricks runtime 16 plus, but obviously within the serverless SQL, serverless you can say cluster, it is not compatible. So you do not need to worry. You should have the knowledge that we just do something like this and it just generates the ID automatically here. See, I have just got this error, identity generator is not defined. And when we just try to generate it, we simply get this error, but you should know about this because this is compatible with the latest, you can say, runtimes, but this is the free one. So obviously you do not get the latest cluster and all. So if you just run your all-purpose compute greater than 16 plus runtime, it should be fine. So that's fine. That's fine. Knowledge is important. So it's fine. Now I will just also talk about something called as, you can say, computed columns for generated. And I think that will also be not compatible, I guess. Let's see, but you should know about this. Computed columns. So what are computed columns? So let's say you have this table. Okay, let's try to copy this. Let's say you have this table, and within this table, you want to create a column called salary hike. Salary hike. Make sense? Or you can say salary after taxes. After tax. So obviously you would not want to fill this data. This data should be automatically filled in the table based on the organization's logic instead of your own logic. Make sense? So in that particular scenario, what you do here, you simply define the logic instead of identity generator function. Make sense? So I will simply say, and first of all, it can be any logic. Any logic. It is saying salary equals to 0. Nice. We don't have these much texts, don't worry. So we can simply say salary column into, let's say you are paying like 30% tax. So I will simply say 0.07. Okay. So this way it will automatically compute this column every time when I will pass this value. Make sense? So you can just have a look at this particular function, and this is amazing. So let's say you want to just fetch the year of a column, month of a column, or let's say day of a column, anything. So you can actually find those things, right? And for that, you simply need to pass event time column. Let's say this is a date column, and all these three columns will be automatically computed. And I think my example is more relevant, like salary and salary after tax. Okay. So if I run this, let's see if it works, because that particular function is not available. Okay, so this is something logical and technical. We can just solve it. So this is saying, hey, whatever you want to just compute, it is just returning something called a decimal, but the return type of this is integer. So you can simply say cast this. Okay, cast this as integer. Let's say as integer. Let's see if it works, because you just need to typecast it. Oh, I think we just missed this particular here, because we need to simply say, hey, cast this as int. So we need to just simply close it. This was missing. Perfect. So let's run this. Is of int, but the column is of big int type. Wow. What do you want, man? What do you want? The expression type of the generated column salary after tax is int. Okay, you want big int. Okay, we can just do that. We are data engineers, so we know like how to typecast the data, int, big int, all those things. So this is done. And yes, you need to just make sure like data type should be exactly same. This is a little pain point, but obviously big data engineers can bear this pain. I know that. So this is done. Let's try to test it, right? Let's try to test it. I will simply say insert into this table. And now the question can be how we can insert this data. Again, very, very simple. The same thing. Yes, we will be talking about how to insert the data in a dedicated, you can say, section. But for now, I'm just simply using a simple scenario of insert into. Okay. So do not say like, hey, how we can just insert the data. It is very simple. I will simply say insert into this, and I will simply say values. Let's pass some values. and we simply need to pass two values, like let's say salary 100, and then let's say name is AA, and then 200, and then let's say BB. Okay, so these are the two values that we are inserting. We are not inserting all the values. Perfect. That's what I wanted to see. Error? Yes. So this is a kind of, you can say, precaution that Delta Lake takes for us. So we know that we just need to insert the values for 2 columns, but in total we have 3 columns, right? So we need to specify the columns here. I will simply say salary and name. Only then it will take those values. Otherwise it will simply say, hey, you are trying to just pass the value for 2 columns, but I have in total 3 columns. That's why it is equivalent to your SQL database. See, the same thing we do in the SQL database as well. So now let's try to query the data. I will simply say select asterisk from this table, first delta API. Let's see what we get. And perfect. So now what did we get? Did I pass this column? Did I pass this column? No, but still I got the value based on my generated column. See, 70, and this is 100, this is 140 and 200. 30% tax, 30% tax. I know it is too much, but still it is what it is. So I simply pass the value for these 2 columns and I automatically got this particular, you can say, column. This is newly added feature, and yes, generated column, this one, like identity column, is like the latest one, like identity generator, that is even not available with this serverless compute. But yes, that's why this is the game changing course, because in this course we're gonna cover all the latest upgrades and all the latest updates. Most of the updates are compatible serverless SQL, so do not feel that way, but there are some features that I will still tell you even if it is not like compatible with this one. Okay, so let's see what do we have next. Let's talk about something a little bit advanced, because being a data engineer, it's fine. You got to know how to create delta tables, you got to know how to work with delta APIs, but after that you will be just creating so many data frames using PySpark, using, you can say, your Spark coding, anything, you can using Scala, anything, right? So once you have your data frame ready, how you can just push that data to a destination in the delta format? That is the question. So when you need to just, let's say, write your data, right? You want to move your data, you want to migrate your data. So in those scenarios, you have to just work with the data frames. Okay, so now we will get to know how we can just work with data frames. Once we have data frame ready, how we can just leverage data frame, like you can say Delta Lake. And we will also looking at the delta log, which is the backbone of the Delta Lake. Okay, so first of all, we need to create a destination, because obviously we just have Databricks workspace. So where is our destination? So in community edition, we used to work with something called as DBFS, but in the free edition we have something called as volumes, which are, you can say, better replacement for your normal DBFS, because you can register those volumes under the catalog and under the schema. So that is the best thing. And you can manage your unstructured data, semi-structured data, structured data efficiently. Okay, so do not make it complex, because it is just a replacement for DBFS. And for now, for this particular course, just treat it as your destination. That's it. Okay, focus on Delta Lake. Okay, so how we can just create the volume? Simply go to the catalog, and here you can simply pick your catalog name, and within this we have the schema we already know. So I will simply say, within the default schema, create one volume. Okay, I will simply provide the volume name. It will be delta vol, cool name. Just pick managed volume, because we want to create a managed volume. Click on create. So this is our volume. This is our volume. Okay, makes sense. So within this volume, you can treat it as your DBFS root folder, if you are familiar with DBFS. If not, you can simply treat it as your parent folder. You can say parent location, parent destination. Within this, you can create multiple folders hierarchically. It's up to you. Okay, so let's start working with it. It's very simple. I will simply go to workspace and then Delta Lake 4.0, Delta Lake, and let's create a new notebook actually. And don't worry, all the notebooks will be available to you. Don't worry. So let's create a new notebook and we'll simply say to Delta Lake. Okay. To Delta Lake. Perfect. So first of all, let's attach it to the serverless compute. Perfect. So I told you that we have a data frame. Okay, let's create a demo data frame. I will simply say data equals 1, 2, 3, or let's say anything like any data. Let's say 100 and any email or any name. So whatever you want to give, I will simply say AA. Then second record will be like this. Let's say 200 CC 4DD. Perfect. And then let's create a data frame on top of it. I will simply say spark dot create data frame. Perfect. And let's actually display it. So this is my data frame. Obviously, like it can be your data frame, it can be your like mapping data frame, obviously. So data frame is a data frame. No matter if you have like thousands of columns, if you have 3 columns, it's fine. So our data frame is ready. Okay. Now, once our data frame is ready, we need to push our data to the destination. And where is our destination? We simply created it. Let me just show you. Simply go to Databricks Ansh. Okay. And then go to your, Delta Lake Ansh. Then go to default, then volumes. Then this is your volume. This is your root folder. Within this, you do not have anything, right? You can create folders. I like creating folders. I will simply say create directory. And I will simply say, you can say, what should be the name of it? Write, or you can say write sync. Okay. Or you can say demo sync. Okay. Demo sync. So this is my directory. I want to save, or you can say write my data to this folder. Okay. Let's do this. And let me just switch to, actually, yeah, it is fine. Okay. Okay, perfect. So what we can do, we can simply say df.write.format, and now format will be delta. Okay, format will be delta. Then you will say dot mode, and obviously if you are familiar with PySpark, this is the code that we use to write the data. And within this, I can simply say append mode, because we have like 4 modes, and I will simply pick append mode because I just want to insert the data in iterations. And then I will simply say dot save. Now what is the location of my folder? You do not need to worry. Basically there's a specific syntax that we follow for volumes, but simply go to the folder and simply click on these double arrows, and that's it. This will simply drag the location for you. Okay, let me just simply run this. What will happen? Perfect, it is done. Just click on your folder and boom, you have your data and your delta log ready. Perfect. As we just mentioned and discussed in the beginning of this video, this is your real data in the Parquet format. This is the delta log that you can say holds all the records, all the, you can say, transactions. Let's say I again want to run this command. Let's say I want to reinsert the data. Let's say this is the second iteration. Perfect. I will simply refresh it and I will show you what will happen. So go to volumes, demo sync. So now we have 2 files. Perfect. Now we have what? 2 files. Perfect. What is inside this delta log? Because we know that this is our first file, this is our second file, but how Delta Lake knows? Because of this masterpiece. I will click on this folder and you will see these files. By the way, you can ignore CRC files. Okay, these are just the commit, or you can say check files, and I think its full form is cyclic redundant check files, so you can simply ignore this. The main thing is JSON files. All the transactions are saved here. All the transactions. Do you know what? This is the first transaction. See, it has a number 0000000. This is the second one 0000001. In the first transaction, it will say, hey, add this partition, or you can say Parquet file. It's same thing, right? Then in the second transaction, it will say, hey, add this file. So every time if anyone wants to read the data, this delta data from this folder, it will simply first of all go to this delta log. It will read all the logs, and it will read all the logs in the specific order, which is 0 and 1, and whatever instructions are there, it will simply follow those. So in these instructions, it will say, hey, in this particular log, it is saying add this file. So it will simply add that file. It will say, hey, add this file as well. It will say add this file as well. That's how it executes your query. Let me just show you the content of this JSON file. You can obviously download it and you can simply see it in your system, but we can also leverage Spark to see the content of it. I will simply say df equals spark.read.format, then JSON, then dot load, and then just insert this particular location. Perfect. We will say display df. So this is the very first log. What it is saying? It is saying add. This is the action. It is saying add. Add what? Add this file. See, exact file name is here. Perfect. If I check the other log, it will say, hey, add one more file. It will say, hey, add this file as well. If we remove any data, if we delete any data, it will simply say, hey, remove. So that's how it takes care of your asset transactions, or you can say atomicity. Specifically atomicity. Why? Let's say due to any reason, your data, let's say this file, this Parquet file, this one was corrupted in between, and this was actually not completed. Do you know what will happen? Yes, this file will reside here, but it will not be read by this delta log. Why? Because there will be no log or transaction for this file name. Okay, and this way it behaves atomicity. Make sense? This way it behaves atomicity. That means even if the file is there, it will not be considered. Why? Because the transaction was not completed. That's the definition of atomicity. That's how Delta Lake manages atomicity. That is your interview question, bro. Just take notes. Make sense? Make sense? Very good. So this was all about, you can say, kind of crash course on Delta Log. I am telling you all these things in detail because these are important. All are important. I hope it makes sense, right? Very good. Now, this is done. Let's talk about something very, very special. It is called schema enforcement and schema evolution. Schema enforcement and schema evolution. Let me just add a heading. So we simply added a heading here. Let's add a heading here. Let's say delta log. Okay. Oops. Let's say heading 1 bold, and let's say delta log. Okay, delta log, and let's create a new notebook. It will be better for you to keep it for your notes and everything. So I will simply say delta lake, attach it, and I will simply close the other files, or you can say other notebooks, because those are not required. Now let's talk about schema enforcement first of all. Okay, schema enforcement. I will say schema enforcement. Now what is schema enforcement? Schema enforcement makes sure that your data is consistent. Let's say this is your target table, okay, and it has, like, let's say 3 columns. So in your source file, in your source, basically it will expect that you will having 3 columns, right? Because you do not want to get any suspicious columns. So it will simply insert it. But by any chance you got one new column, it will simply fail the flow and will simply say, hey bro, this is not allowed because I just have these columns. So that's the power of schema enforcement, and that's how it tackles the scenarios where pipelines can fail due to, you can say, schema mismatch and everything. And you can say it can lead to great disruptions as well. So that's how Delta Lake is very, very powerful to just take care of schema enforcement. Let me just give you an example. Let's say, so we already know that we have this particular volume here. Okay, we have this volume. Makes sense, like this data. And what is the, you can say, data schema for this? If you remember, we can just simply open the second notebook, second Delta Lake. Okay, perfect. So this was the data frame, right? This was the data frame. Let me just copy this data frame here. Let's try to just add one more column. Make sense? Let's say in this particular batch, we got one more column, and in this column we just have, let's say, 1 and basically 1 and basically 1 and basically 1. Make sense? And let's add the schema here, let's say sus column. Okay, we can see this data. Obviously there will be 4 columns, but if I will try to write this data to this particular destination, this one, it should fail because that's the power of schema enforcement. Let's try to see if it fails or not. Okay, so I will simply copy the code for writing as well, and let's see what happens. So let's see, it should fail if our schema enforcement is working fine. Perfect, we are seeing an error. It is saying, hey bro, schema mismatch detected, so I will not allow this data. Perfect. That's how you can secure your destination tables, destination delta tables, or you can say delta data or data in delta format, whatever you want to say. So this is the power of schema enforcement. Make sense? Make sense? But let's say in some scenarios, you are building a solution in which schema mismatch is expected. That means schema evolution is expected. That means you want to intentionally evolve the schema. In those scenarios, you have to use something called as schema evolution. Make sense? Schema evolution. In those scenarios, you have to leverage schema evolution. Now, just tell you one thing, how you can just evolve the schema. It is pretty much, you can say, impossible without Delta Lake. But with Delta Lake, it is just a matter of few seconds. Let me show you what will happen and how it will happen. So let's say you want to write this data. I will simply write df.write, or basically the same command. Okay, but I just need to add one more option. I will simply say dot option merge schema true. The moment I say this, let me just run this and let me just show you. The moment I run this, it is fine, and you will also see the file here, bro. See, there should be 3 files now. There are 3 files and it didn't break. It didn't throw error. Why? Because this time it actually merged the schema. Make sense? That's how schema enforcement and schema evolution work in Delta Lake. I hope now it is clear. Now in the next section, let's try to master how we can read the data, read the Delta data. You will say, it is very simple. We can simply use select asterisk from table name. Yes, it is very simple when you have table. But when you do not have table, when you just have Delta data, then let's say you want to read this data. How you will just read this data? How? That is the thing. I will just tell you how you can just. Now, let's say you want to read the data. Obviously, we have already seen how to read the data if they are tables. Let's say this is a table, default table. So if you just want to read the table, we can simply say something like this. Let's insert some more cells. So let's see, select, right? Let's say read data, or you can say read delta data. Make sense? Let's say read delta data. So if you just want to read delta data, if that is a table, it is very simple. You can simply say, hey, if that is a table, let's say if it's a table, you will simply say select asterisk from data lake Ansh dot default dot, let's say first table API, whatever we have, right? We can simply say select asterisk from this table. And this is pretty much similar to your SQL syntax. So that is fine. That is not a big deal. Now, let's say you want to read the data which is in the delta format and we do not have table built on top of it. In that particular scenario, you will use a connector called delta. So if we have data lake instead of table, we will simply say select asterisk from. Now here, instead of table name, we will simply write delta dot, then you need to insert backticks like this. So how you can just also insert it, there's a key just above your tab key. So this is the backtick. Okay, now I can simply pass the location. So I know this is the location, right? So I will simply pass this and then I can just query this data, delta dot and my location. So basically this is, and why we are seeing nulls here, and you know better because we evolved our schema, right? So it is perfect. This is the updated schema. Wow. Now you can say this is actually equivalent to a table itself, because delta lake is actually like table in itself, right? So if you want to just query it like a table, just go with this command and it actually behaves exactly as table, and you can see it, right? You can see it, right? Perfect. So this was like a quick, you can say, way to query the data. So you do not need to every time create a table and then just do anything. No, you can directly just read the data sitting in the data lakes in the delta format. Okay, now let's talk about something related to our previous session, which was schema evolution. Let's say I have a requirement where I want to create a data frame. Let's say this is the data frame. Let's create a new data frame. Okay, let's talk about, it's called basically schema override, and it is very important. Schema override. Perfect. So let's say I have a data frame which has columns such as, let's say, customer ID, or you can say income, then name, and this can be, let's say, tip. Okay, I have this data frame. Perfect. Make sense? Now I want to write my data in the same folder, but this time I want to overwrite my data. Simple, like using PySpark overwrite command, right? Let's try to do this and let's see what will happen. So it will simply say df.write.format, and format will be obviously delta dot mode, and we'll simply say overwrite because we want to overwrite this folder, right? Then dot save, and then this particular path, which is this one. Let's try to do this and let's see what will happen. Error. Perfect. Why error? It is saying schema mismatch. You will say, Ansh, Lamba, we want to overwrite this particular folder. Why it is saying schema mismatch? So the thing is, whenever you want to overwrite any delta folder, right? Yes, if you have same schema, listen to me carefully. If you have same schema, you can overwrite your data instantly, okay, without any hustle, because it will simply replace your old data with the new data. But if your schema is also changed and you want to override the data, then you need to, it's your responsibility to override the schema as well. Why? Because your data is in these files, right? In the Parquet files, and your schema is in the delta log. So you have to explicitly tell it, hey, just overwrite my schema as well. Make sense? Very good. So I will simply say dot option and then overwrite schema true. The moment I say this, now it should work. Perfect. And now let's refresh it. And if we just try to query this location for one more time, which is this one, we should not see this data, we should see the new data. Let's confirm. And perfect. We have the new data and we no longer have the previous data. Perfect. That's how you work with overwriting the data. And this was really, really important because in the real world, you do not want to just create new folders every time. You should know how to overwrite the data. And you saw the error when you just tried to overwrite the data using your normal PySpark option, right? So these are small things that you have to take care of. Perfect. So now we have understood a lot of things in Delta Lake. I know. Now let's try to create a new notebook and let's try to cover something called as DML, or you can say data manipulation capabilities within Delta Lake. Okay, let's create a new notebook. Perfect. So within this, first of all, I will simply rename it. I will say 3 Delta Lake. Perfect. Renaming the element field. Woohoo. Why? Delta Lake. Perfect. So, I just renamed my, wait, what happened? Oh, we already had 3 Delta Lake. Wow. So this will be my 4th Delta Lake. Perfect. So now let's talk about DML. This is very important because DML is something that we cannot ignore. And we cannot ignore because obviously we have to manipulate our data as well, right? Let's try to create a new folder, okay? Because we're gonna just cover something very special. And within this volume itself, I will create a new folder. It's called DML sync, okay? Because you will learn something very special. So let's say I have this data frame. Let's say I have this data frame. Where is that? Let's say this one. Okay. I have this data frame and I don't want to see it. I will simply write this data frame to that new folder. Right. And I will simply say df.write, and obviously I do not need to use this overwrite command, and I will use simply the append mode, but that's fine. Okay, you can even use overwrite append mode. Perfect. And we'll simply create it in the DML sync. Perfect. Let's try to write it and let's see what happens. Delta Lake default volumes, delta volume, DML sync. Perfect. So this is done. We have one file here. Perfect. Let's try to insert new data. Okay, let's say 2, not 2, basically let's say 5, then 6, and then 7, and then 8. Okay, let's do that. And let's try to query this. Let's see how many records do we have. I know there should be 8 records, but still let's see. And how we can just query this, we just got to know like this. Perfect. Perfect. See, 1 2 3 4 5 6 7 8. Very good. Now I want to, let's say, and first of all, there should be like two files, right? There should be two files. So now, and it is just refreshing. So if you also see this kind of thing, just refresh the whole web page and it should be fine. So sometimes it takes like, it's kind of bug. Okay, so volume, delta volume and DML sync. Perfect. So we have two files so far. Now, let's say I want to update one thing. I want to update this ID's income. I want to say 1000. How we can just do that? It's very simple. Let me show you. If you want to say update, okay, if you want to update it, I will simply say update, okay, then table name. So now I do not have any table name, right? I do not have any table name, but I have something like this, delta dot backticks and this particular location. Okay, I can do that. So it is equivalent to table name, don't worry. I will simply say set income equals 1000 where ID equals 5. Okay, let's run this. It will simply update my data. Now with ID, okay, it's not ID, it is customer ID. Okay, it will simply update my data which is in the delta format, and that's how you just run your DML commands, and it's so powerful. I will simply say select asterisk from delta dot backticks and then this thing, and you will see value will be changed. It should be changed to 1000. Perfect. See, now it is 1000. Very good. So how it actually changed these things? So basically, whenever we make, I will just tell you both the scenarios, okay, and I will just show you the delta log after that, and I will just discuss both the scenarios. So here what happens, so for now you had two partitions, like two Parquet files, 1 and 2, right? In this ID you had one, like in this file you had 1 2 3 4, and this you had 5 6 7 and 8. Makes sense. Okay, now this is a kind of, you can say, delta log which is sitting here, and it has so far two, you can say, transactions, which is saying add one file and then it is saying add second file. Okay, perfect. 0000.json, 00001.json. When I updated the data, which file had the data which needs to be updated? It is this one. So do you know what will happen? It will simply recreate this partition with the changes, and the new partition will look like this. Oh, okay. And now this new partition will be added here. Okay. Now the question is, this is updated. That means its data is changed to 1000. It is inserted here. Why it didn't create duplicate? So because delta log took care of it. Delta log said in the transactions, this is 00000, this is 00001. In the 00002.json, it will say, hey, just remove the second partition and add the third one. So whenever I am just running my select statement, it will read first of all this, add one, so it will simply add this. It will read add two, it will add this. Then it will read my third log, it will say, hey, remove this and add third. That's how it goes. This is the method that we are seeing it here. Make sense? And let me just show you. Let me just refresh it and you will see the same thing. Let's say default, volumes, delta volume, DML sync. So perfect. Perfect, perfect, and perfect. Now, for now, you need to imagine something. Really? Yes, you need to imagine something. Just forget about this particular view and you need to trust me whatever I have said. Okay? Okay. You need to imagine that you just have 3 files. Okay? Let's say these 3 files, just 3 files. And same way, one is updated, one is removed, and third one is added. But what is this fourth file? What is this fourth file? So this is the new update, and let me just tell you why it happened. So you understood the previous concept, the traditional concept, but after the deletion vectors, now what are deletion vector? We will just talk about deletion vector, don't worry. After the deletion vector is like automatically enabled on your Databricks workspaces everywhere in the Delta latest features. What will be happening when we have deletion vector enabled? So it will simply say you have this file having 1, 2, 3, 4. Then you have second file 5, 6, 7, 8. Perfect. This is changed. So this file is changed to this one. But do you know what? It will not rewrite all the data. Okay. It will only write the data for the updated records. So how many records did we update? Only one. So it will be having data only for 5. Okay. And it will be inserted here. Okay. And this information will go to the Delta log as well. Like this. Okay. Now the game changes. It will say, hey, in the first transaction, it will say add this, add 1. In the second one, it will say add 2. Makes sense. In the third one, Ansh Lamba, if we say remove second and add 3, we will lose the data, right? Because we do not have 6, 7, 8. Yes, you are right. So this was previous approach. But with the deletion vector, it will not say remove 2. It will say add 1, add 2, then remove 2. Yes, wait. Remove 2, add 3, and add 2 as well. Ansh Lamba. If it adds 2, it will simply bring the 5th record again. No, because this add 2 is special. Because in this add 2, it will say add 2, but with deletion vector. With deletion vector. Now, what is this deletion vector? It is a kind of a placeholder which will be applied on the 5th record. So it will simply say, hey, this record is changed. Hey, this record is updated. So yes, add this record, but do not count this 5th ID because this is flagged. And how does it know this? Using this particular vector. This is the deletion vector. Make sense? Make sense? Ansh Lamba, I know everything. I now understand everything. But, hold on. Why do we have 4th file? Yes. Why do we have 4th file? Now, this is a kind of optimization technique that Delta Lake automatically performs. So basically tell me how many files we are managing. 3. So it simply says, hey, do not manage 3 files. I will simply coalesce all these files into just one. So this is a kind of optimization technique that Delta Lake follows. So this is not like a wow thing. Obviously it is wow thing from, you can say, data processing perspective. But if you just want to understand what is happening here, it is not like totally different. It is just like an additional step. Like once everything is done, hey, just add cherry on the cake. That's it. But this is it. This is the everything, like what is actually happening behind the scenes. I tried my best to make you understand what's going on behind the scenes, behind the curtains. Okay. So these are like senior folks things, but I know like competition is really rising and really quickly. So it's my duty to just make you understand everything. I hope you understood. And if yes, just drop a lovely comment. Why you are waiting, man? Why you're feeling shy? Why? Don't feel shy, bro. Don't feel shy. So this was all about your DML. Obviously you can perform deletes, updates. So everything will be happening like this. Make sense? Make sense? I hope you understood this concept nicely, because this is the, you can say, building block of your understanding in Delta Lake. Let's see what do we have next. So what's exactly are deletion vectors? Let's talk about it. So we have already seen, you can say, the application of deletion vector, and I would say that is the most important thing, even you can say more important than the definition itself, because once you understand the application of it, you can just tell the definition as well. So what can be the definition of deletion vectors? Just imagine. It is nothing but, in simpler terms, it is just like, let's say, it is just the storage cost optimization technique. Storage cost optimization technique. How? Because we know that whenever we just, let's say, update anything, so instead of, let's say this is the partition that we are updating, right? This is the whole partition. In this, let's say we have 1, 2, 3, 4, and let's say 1 million plus rows, for example. Okay, obviously we will not be getting 1 million plus records within just one Parquet file. Let's say 100k, it is like, you can say, realistic. Or let's say 1000, let's say 1000. Okay, let's say 1000. So now in deletion vector, let's say I'm just updating only this particular key. So instead of rewriting the Parquet file with 1000 records, it will simply write the data with only one key. So this way it actually optimizes the cost, because it is not occupying a lot of space. It is just rewriting the partition with only with only this data which is required. That's it. So this is the, you can say, definition, or you can say this is the concept of deletion vectors. And you have already seen the application of deletion vectors, how it is so helpful within our, you can say, Delta Lake. Deletion vectors were not there before. Okay, it is like, you can say, newly added, not like newly added, but yeah, it was added, I think, after 2.4 something. So it is not very new and it is not very old. So it was added like more recently, I can say. But yeah, deletion vectors were not there in that particular book that I read. So I was like, one day I was just like practicing something and I saw some suspicious behavior within my Delta log. I was like, what's happening? And I didn't know about deletion vectors at that time because I didn't read it anywhere. And I was like, what is happening? What is happening? What is happening? And after spending so many hours, then I read one article in which I got to know, okay, now they have launched something called as deletion vectors. And then I was like, oh, okay, that makes sense. Then I just digged deeper inside this topic. Then I literally got to know, like, this is really game changing and it is really helpful. Okay, so this is all about deletion vectors. Let's see our, you can say, advanced features available in our Delta log. Advanced features, yes, let's talk about it. So within this notebook, we were learning about some DML commands like update, delete, insert. That is fine. But there is very important command that is like non-negotiable for data engineers. It is called upsert. Ansh, Lamba, it is called insert, not insert. It is upsert. So what is upsert? Upsert is basically the combination of update plus insert. Or you can say it is very popular with the second name called merge command. So in this, what we do? So let me just first of all show you the example. So let's say you have this particular data for these customer IDs. Okay. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8. Okay. Now, if I say, hey, I have the another batch, or you can say another iteration for my this destination table. And in the new batch, I have these records. Let's say 1, and the name is, let's say, XYZ instead of AA. Okay. Then I have 9. Then I have, it can be, let's say, ZZ, and I have 10, and it has, let's say, EE. So what will happen? If we apply insert, it will simply add these 3 records here, obviously, here, right? But they'll be duplicate with one ID, right? So when we build, you can say, silver and gold layers, we cannot afford duplicate records. Make sense? Or if you are building slowly changing dimensions, then also you need to apply upsert, especially with the type 1. Okay, so it goes hand in hand. with slowly changing dimension type 1. So basically how we can just tackle with these scenarios, because in PySpark we just have 4 modes: insert, not insert, like append, it's the same thing, append, overwrite, and then you have, let's say, error and ignore. I highly recommend they should also include something called as upsert as the mode. It will be much easier, but for now we do not have that. But yes, we have something called as merge command. Make sense? So how we can just apply a merge command, or basically upsert command, within our destination table? So we have to use something called as delta table library for that. Yes, that is the most efficient way. Some people prefer using with the SQL API. I do not prefer that. I prefer doing it with the Delta API. I feel much more flexible with it because I do not need to create temporary views on top of my data frame. So I can directly write my data with the upsert approach. So let's say you have this data, this destination data here, right? So this is our destination DML sync. And what should be our DF? Let's create the DF, like the new batch for our DF. And our DF will look like this. Let's say, first of all, let me just tell this particular notebook that, hey, this is an upsert command. Okay, upsert. So I will simply create a new batch of DF. Okay. And in this new batch of DF, I will simply create IDs such as 1, and I will rename it. I will simply say, hey, XYZ. And let me just confirm this is the same one. Yeah. Perfect. And I will add 9 and I will add 10. Make sense? Just 3 records. Just for the demonstration. So let's create this particular batch and let's actually see it as well. Display DF. And I hope you understood the requirement, like what exactly we are trying to do. Okay. So perfect. As you can see, this is our new batch. And in this new batch, we just want to say, hey, customer ID 1, customer ID 9, customer ID 10. Okay. Because we now want to apply upsert, because we don't want to insert these records. We need to upsert. That means if the record is there, then simply update it. If the record is not there, then only insert it. Make sense? So let's do it. For now, we will simply import one library called from delta.tables, import delta table. Delta table, you can say, module is very, very helpful for, you can say, modern day data engineering. So what I will do, I will first of all create a delta object on my destination table, something like this. Let's say DLT object equals delta table dot for path, because obviously we do not have any kind of table on our destination, right? So we'll simply say for path and spark is our variable, and then this is my destination object. Perfect. Once I do this, then I simply need to apply the merge command. Merge command is very simple. You simply need to say DLT object, which is your target object. I will add an alias. Why? Because it promotes readability. I will simply say TRG. TRG means target. Okay. Then I will say dot merge, because I want to merge it with my source, and my source is df.alias source. Okay. Then what will be the merge condition? I want to merge my data on trg dot customer ID equals src dot customer ID. Make sense? Perfect. Once it is done, once it is merged, now I will pick my tools. So I will say if my ID is matching with the destination, I will say when matched, I will say update all. That means if the ID is matching, simply update all the columns. Okay. But if my ID is not matching, when not matched, then simply say insert all. Simple, and then execute it. This is your command. If I run this, you will see that it will insert only the new records and it will update the existing records. So it is now performing the merge condition, and this is how you apply the upsort within the Delta Lake. It's very simple, very simple. So it is done. Now let's try to query the data. Let's say select asterisk from delta dot and then volume. Okay, let's see. Perfect. As you can see, we just have updated value plus the new records. We do not have duplicate values for customer ID equals to 1. That's how you apply upsort. Simple. It's pretty much simple here in Delta Lake. Okay. And yes, obviously now it is simple because now you know how to apply it, right? So this was all about upsort, and you can say it was all about how you just manage the merge condition and merge situations in your code. Okay. Now let's see what are the powerful features of Delta log itself other than merge. So basically we know that we change the schema a lot. What do I mean? Let's say you have this particular schema. Now this is registered, like this schema is registered, right? Makes sense? This schema is registered. But what if I want to rename this column? What will happen? So this is called schema level changes, or you can say Delta log level schema changes. Make sense? No? Let me just tell you what will happen and how it will happen. So first of all, I will just show you the volume. How does it look like? So in the Delta volume, I will simply go to DML sync. And as you know, like we have so many changes here. So what I will do, I will simply create a new, you can say, folder here. And I will name it as create directory. And this will be called as, let's say, Delta log, not Delta log, let's say schema level. Okay. So what are we trying to achieve here? Let me just show you what are we trying to achieve here. So let's say this is my data frame, and let's create a new notebook for this particular exercise. We will say 5th Delta Lake. You can treat these notebooks as your chapters, so it will be very good for your notes as well. So enjoy. So let's say this is your data frame. Okay. And let's write the code to actually write this data to that location. Delta, then dot mode can be append, then let's say dot save, and save will be your location of your volume of this folder. Okay, perfect. So let's run this as well, because we just need to write this data. Okay, so just rerun this. Sometimes it throws this kind of error when your quota limit is exceeded, maybe due to concurrent, you can say, notebooks attached. So simply turn off all the other ones, and if it happens, you simply need to wait for, let's say, 15, 20, 30 minutes. It will be up and running very soon, because this is using like free resources, so it can be exhausted, but do not feel like it will be permanently exhausted. No, it takes some time to just, you can say, refill your resources. So I think, yeah, that is the issue, because I'm so sure if I just go to compute, obviously I cannot see it here because we do not see like serverless compute here. But if you just go to workspace, okay, if you just go to chapter 5, if you just, let's say, terminate it, okay, because I have seen this particular kind of issue previously as well, so it is fine. It's not a big deal. So it is just trying to, let's say, fill up your resources. So if it happens intermittently, so you do not need to worry. If it happens, you can retry, and still if it happens, you can just wait for, let's say, 30 minutes, 15 minutes, something like that. Let's reattach it. Let's see if it works. because you cannot expect everything from the free edition. Obviously, you need to just compromise with your cluster performance and all, because yeah, it is what it is. Let's see if it works. If not, we have to wait for, let's say, 15-20 minutes, or we have to just use a previous connection, but now it is working. I guess it is fine. So you can just try these things, reattaching and terminating the cluster, then restarting it, right? Okay, perfect. So this is my data frame, okay, and I want to write it here. Okay, perfect. So if I go to my volumes, so this is my volume, and I know that this is my file, right? And if I just try to read this file, okay, just the Parquet file, not the Delta format, just this Parquet file alone, what will be the schema? You will say, hey, the schema will be exactly same. That's correct. Let's try to confirm this. I will simply say df equals spark.read.format, and we are not reading Delta format, we are just reading the Parquet file. That's why I'm just writing Parquet. Then I'll simply say dot load and just pass this location, and let's say display. Okay, display df. Perfect. Okay, what is the issue? A transaction log for Delta was, oh yeah, makes sense, because it will not allow you to read the file alone. You have to download it, and you have to then just put it in the different folder, and then you have to just read that folder, like that folder alone, instead of this Delta log as well. So that can happen, not a big deal. But let me just tell you what will happen if I just download this and I can just upload it. Not a big deal. But the issue is, let me just remove this. If I want to change the schema, okay, let's say I want to rename it with, let's say, this column. Instead of name, I want to just write customer name. You will say, in normal SQL databases, we can easily just do it using alter command, and it should work. You can do this thing here as well, the same way, exactly the same way. But you know what will happen on the file level? So if I just rename this particular, you can say, folder, let's say not folder, like column, it will rename this column, yes, but it will not change the schema of this file, of this Parquet file. That means the schema of the Parquet file will still have the column name equals to name instead of customer name, but it will be changed here in the Delta log. That is the power of schema level changes, or you can say Delta log level schema changes. Make sense? So let's say I want to alter this table name. So I will simply write alter table, and I do not have table, so I will simply say delta dot that particular location, which is the schema level. I want to say alter column, okay, and I will add the column name, which is name, and I will say rename to let's say customer name. Okay, now I will just simply run this. Just the syntactical error, we simply need to remove alter, because obviously why do we need to put alter here? We simply need to say rename, that's it, rename column name to this customer name. Let's run this. Now we will see one error which is expected, and it is saying column rename is not supported for your Delta table, please enable column mapping. Yes. What is this column mapping? So if you want to just perform some schema level changes, you can say Delta log level schema changes, you have to enable, you can say, this mapping mode. Some people say it column mapping, some people say it like blah blah blah. So basically, in short, there is something called as reader version and writer version. So we have to enable reader version equals 2 and writer version equals to 5, and this enables our mapping mode. Okay, so there's a code for it. I can simply click on diagnose error, it will simply give me that particular code to enable it. You can also search it on the documentation, but quicker way and easiest way is this one. So this is the code. See, reader version 2, writer version 5, and column mapping mode equals to name. So this is not the column name. This is the mode itself that we want to enable the mapping. So what is the importance of it? Let me just try to tell you what is the importance of it. So I will simply insert this code. You can either copy or paste, or you can simply use these two arrows and the code will be here. So what is the importance of it? So the thing is, this is our delta log having different schema. These are the files having different schema. So we need to enable the mapping so that every time anyone reads the data, delta log can just map the respected columns like this. Let's say this column with this. So that's why we have to enable the mapping. So if I just try to do this now, we will be able to do it because now column mapping is enabled with the reader version 2 and writer version 5. Okay. So now this is done. If I just try to query the data, I will simply say select asterisk from delta dot backticks and volumes schema level. Let's try to see. Perfect. Now this is changed. Yes. If I just try to read the delta log, okay. If I try to read the delta log, I will simply say, and I think I have 2.json. Okay. I will say df equals spark.read.json, or let's say format JSON, then dot load, and this is my path, right? This is the one. Perfect. And let's say df.display. Okay, perfect. So in this particular, you can say log, which is the latest one, it will show you the metadata as well. So it is saying, hey, you have enabled the column mapping and these are all the things. If you expand it, you will see all the information here. And now it is saying, hey, the schema string is this one. This one. See? Can you see this? Now it is saying customer name. Now it is saying customer name. Make sense? Make sense? That's how it performs your column mapping. And to which column it is mapped? It is mapped to the name column. So the delta log level schema name is customer name, but the file level name is, which is called physical name, it is called name. So whenever in our Parquet files we have something called as name, it will automatically convert it into customer name. That's your schema level changes. So your physical files are not being rewritten every time if you are just renaming your schema. That's how you save cost. That's how you save resources. That's how you boost the performance. Make sense? Make sense? Make sense? So this was all about your schema level changes. Okay, I hope it makes sense. Now let's try to look at some amazing stuff, because this will actually be very helpful if you are a new data engineer and if you are just trying to query data for the first time. What are those things? Let me just tell you. So now let's talk about table utility commands, and I would say this is one of the most important topics that we have for, you can say, Delta Lake. Why? Because we have some powerful commands that you have to learn and you have to explore. So I have basically created a long list of all the commands so that I will not miss any command, because I want you to learn all the commands. Okay, because every command is important. I cannot skip any single command. So let's cover it one by one. Okay, so I will just cover all the commands and let's see what do we have first. Okay, let's talk about data versioning. So what is data versioning? Let's say, or just before even data versioning, let's talk about the detail command. What is detail command? By the way, I'm using night vision mode, so do not worry, your screen is right. So detail command, like what is detail command? Let's say you have created a table. Okay, table or any kind of delta data. If you want to just explore that, if you want to, let's say, find the details based on that particular table, how you can just do that. So for that particular thing, you simply use detail command. Okay, either on the table or on the delta path. So when you run this command, you can simply find a lot of things that will not be available in your maybe UI, or if it is available in UI, you do not like need to just go to the UI again and again. And this has two parts basically. One is detail and one is extended detail. Okay, let's try to cover all these commands, and one by one we're gonna master each and every command. Okay, let's see. So we are back on our Databricks workspace. So let's create a new chapter. Okay, because in this we have schema level changes. Let me add a text for you. Metadata, or let's say delta log level. Schema changes. Okay, perfect. Let's create a new notebook and let's attach it with the serverless compute, and let's say 6th Delta Lake. Okay, this is your free book, a kind of covering all the chapters. Okay, 6 Delta Lake, and it can be your cheat sheet as well, like just to give a quick read before your interviews, and you will be like, woohoo, interviews cleared. And do not forget to comment on this video and tell me like, okay, you got selected. Okay, so let's talk about, you can say, table utility command. So let's say I have this data, right? I have this volume in which I have the data. I have tables as well. I have volumes as well. So I can just use anything. Let's say I want to get to know more about this particular table. Okay, so what I will do, I will simply write first of all the heading and table utility commands. Okay, perfect. Run this table utility command. So first of all, I will simply say describe. Okay, describe, because I just want to describe the table. You can also remember it like this because you want to describe it, right? So if you want to describe it, you will simply say describe and just change it to SQL. Why? Because it doesn't recognize it as a SQL command, so you have to just manually set it. So describe and then simply the table name. Let's say I want to say describe delta lake Ansh dot default dot first table. Okay, let's say I want to run this. So it will simply give me the whole, you can say, set of details in which I will find all the necessary details which are required and associated to this table only. If I want to see, hey, if it is managed or not, hey, if it is like all the things, you will see a lot of, you can say, key value pairs, and you can say a table of information. So let's wait. It should not take much time. So it has just given this thing, which is column name, data type, and comment. Make sense? So these are our columns and these are our data types. This is like quick description of your tables. Quick. If you just want to see the schema and all the things. If you just want the detailed version of it, as I just mentioned, we have two versions of it. I will simply say describe extended, and then let's say delta lake default or first table. Describe extended detail. Okay, and by the way, we also need to say detail here as well, because we just used describe, so it just described the table. Now we can simply say describe detail, so it will simply give me some more information, some more. Format is delta, table ID is this one, name is this one, description is empty, location obviously is not visible because it is in the default storage location, created at, last modified, partition columns, clustering columns, number of files, all those things, right? Minimum reader version 3, writer version is 7, and table features append only, deletion vectors, everything. See, table features, it has automatically enabled deletion vectors, as I just mentioned, right? Very good, because now it auto enables deletion vectors, and by default in the tables we get this property which is append only. Okay, so all these things are here. Make sense? So this is the power of detail, you can say, command. If I say describe extended detail, I will see a lot more information about my table, because as the name suggests, the table or view detail cannot be found. Extended detail. Oh yeah, we simply need to say describe detail and then extended. Yeah, makes sense. So we do not need to use detail with extended. We can simply say describe extended, and it is, you can say, the package of detail within it itself. So now in the latest versions, we do not need to describe detail. We can simply write describe extended and that's it. It works. So yeah, all these kinds of updates have to be told, right? So now I am seeing much more detailed version. I have data types, I have catalog, I have database, I have create update time, I have type, I have provider, I have is managed location true, I have predictive optimization, I have table properties, everything. See, every single thing. So this is a kind of extended version of your describe command. Make sense? And if you just want to use detail, you can just use this as well, detail. So sometimes I feel detail and extended are pretty much similar, but extended gives you the better view to just have a look at your, you can say, properties and all that information. But here you have to just drop and just drag it down towards right and just have to you can say extend these columns. So that is not very convenient, but yeah, extended version I do personally like. Again, it's personal choice. You can like this as well. Like both the commands are there, right? So you should know both the commands. Now let's talk about something called as data versioning. What is data versioning? So we know that our all the transactions, let's say these are our files, 1 2 3 4, all these files are being stored, like not files but yeah, metadata and all the transactions of these files stored are being stored in the delta log. Okay, now if I want to see the versions of my current table, what do I mean? Let's say this is my table which is built on top of this data. Okay, I want to see the version because obviously let's say I inserted this data, so that creates one version. If I change some data, that creates another version. If I delete some data, that creates another version. So every version is stored in this delta log. But what if I want to see and analyze all the versions, like what actually is happening? What actually is happening? So for that particular reason, you have to use something called as data versioning in delta log, and it is the backbone of your time traveling as well. What is time traveling? We'll talk about it, don't worry. But your data versioning is the backbone. Let's see how we can just actually leverage data versioning. Let's say I want to leverage, or let's say I want to see all the versions of this table, of this delta data, all the versions, like whatever we have done so far from the starting. Can we do that? Yes, with the help of data versioning. I will simply say describe. Describe command is very helpful. You can either use describe extended, describe detail, and this time we are using describe history. And I will simply say delta dot, this is the location, DML sync. Okay, now let me just run this and you will see the detailed versions, all the things. Either you have inserted the data, everything. See, it started from 0 because it starts from 0. It is saying at the 0th version you write the data, that's correct. And for 1th version you again write data, that's again correct. Then on the second version, or basically you can say version number 2, you updated the data, that's correct. Then it is saying, hey, on the version 3 you optimize the data, that's partially correct. Why? We didn't manually optimize our data, but as you know, deletion vectors automatically optimize our data, right? Remember the deletion vector section? If not, just rewatch that section. So this is optimize command, yes. Then we applied merge, remember? So it captured that as well. Then it again optimized the data automatically, because now with the deletion vectors enabled, it automatically optimizes the data with any DML command, right? So that's how it takes care of all the versions, 0, 1, 2, 3, 4, 5 and so on. Every single version. And not only this, you also have timestamp. You also have timestamp. Very good. Now, what is the advantage of it? Obviously you have like all these metadata. What is the advantage of it? If I talk about, hey, what is the advantage? Advantage is very simple. Now let's talk about time traveling. Let's say you made a change which was not required, but you made it by mistake, or not by mistake, you intentionally made that mistake, but now you want to revert those changes. What do I mean? Let's say I applied the merge statement here. Okay. But now I got to know, hey, that data was corrupted. Those changes in the data, which was name XYZ, was not actually required. Now I want to revert it. Can I do that? Yes. With the power of time traveling, you can do that. So what exactly we are trying to do? We are simply trying to move our current state of the data. So basically our current table is sitting at version 5, right? Which is the latest version. I will simply say, hey, move my table or data to version 3 so that this merge operation will not be seen. So we will only see the data at this particular state. Are you sure we can do this? Yes. What I will do, I will simply show you, first of all, the current state. I will say select asterisk from delta dot backticks and then your location. Okay. Perfect. So currently we have this data with the name XYZ for ID1. Now I want to say, hey, I do not want to update this record and I do not also want to insert these records. Basically, I want to undo that merge operation. I will simply use time traveling. How I can just use that? I will simply say restore, okay, restore, and obviously SQL, restore, and then table name. Table name is delta dot backticks and then this, because we do not have table name, so we are simply referring delta. So restore table name to version as of 3. Okay, let's run this. Let's see what happens. So it is completed. Perfect. So now we can simply say, let's try to query this table again and let's see what happens. See, this is the same table. I'm querying it again. Let's see the results. Okay, perfect. See, I do not have 9th and 10th record, and my 1th ID also has the previous name, which is AA. That's the power of time traveling. That's the power of time traveling. Wow, this was insane. Yes, I know, this was insane. This is the power of time traveling. You can, let's say you just deleted all the records from the table. You can even undo that part using time traveling. Make sense? Very good. Now you can also use this version column that we used, but along with this, you can also use this timestamp as well. Really? Yes. So what will happen? You can simply say, I want to go to a different timestamp. Let's say you want to go to this version 2. So obviously you can simply say restore table name to version as of 2, right? To this particular version. Let's say you want to, what did we update in this? Okay, we can just see the picture what we will be updating here. So let's say you want to say, I want to go to version as of 2. Okay, but you actually do not want to change the state directly. No, you can even use time traveling with the select statement as well. Let me just show you. Let's say this is the select statement. I will simply say version as of 2. Perfect. I can even use this time traveling with select statement as well. Let's say I just want to see the data, how my data was looking before. That's it. So in this particular one, we have this data, and I remember that we changed something, and let's say to version as of 5, just to confirm. So we should see the latest, you can say version, which is the latest state. Perfect. We have this particular data, right? With all 9, 10. So this way you can actually perform time traveling. You can either go in the past, you can either go to the, you can say current state or latest state using versions. But you can also use something called as timestamp. Let's say I want to use timestamp as of, and then I will simply provide the timestamp from here. I can simply copy it. Okay, this is the latest timestamp. Let's see what happens. Let's see. Okay, perfect. So this is the data that I am seeing, right? Because we just use the latest timestamp. If let's say you want to use this timestamp, what will happen? Let's say copy. Not this one, basically the third one, this one. Let's see what happens. Perfect. So I am seeing this particular version which was at the third. So you can either use your versions or you can use timestamp. The good example of using timestamp is you do not need to use exact timestamps. Oh, really? Yes. Let's say, because this is the state of the table at this particular time, right? 12:33 something. If I want to see the state of the table at, let's say, 12:36, let's say, so what I will see, what I should see basically, I should see the same data, because this data is not changed until 12:52. So you do not need to use exactly your, you can say, timestamp. So you can also say, hey, what was the state of my table 2 hours before? So for that, you do not need to see the versions or timestamp. Simply put timestamp 2 hours before and that's it. You will see the timestamp, or basically that state of the data which was there 2 hours ago. Make sense? 2 hours ago. Simple. And if you just put the exact timestamp, obviously you will be just land, you will land on the exact, you can say, change timestamp, because at this timestamp the data was changed. Make sense? That's how you can just work either with the versions or timestamp. I like using versions if I just want to get to the exact version, but if I just want to see the data for, let's say, how was the state of my data last night, I can simply use timestamp. Okay, this is the power of, you can say, data versioning and time traveling. Let's see what do we have for our more utility commands. Let me just check my list. So we covered history, okay, detail, yes, okay, restore is covered. Okay, let's cover this particular thing which is called table properties, and this command is only and only available for your tables, not your delta data. Okay, table means like real table that we have, like first API or something like that. So you simply need to say, if you want to see the table properties, by the way, what are table properties? Table properties can be anything. Let's say you are enabling deletion vector, that is your table property. That, let's say you are just enabling merge command, that is your table property. So if you just want to see table properties on any table, you will simply say show table properties and then just table name, which is delta lake Ansh dot default dot first table. Okay, perfect. Let's run the SQL command and let's see what it returns. Okay, perfect. So this is the table properties. So I have deletion vector on, this is my table property. Append only, this is my table property. Deletion vector supported, this is my table property. Invariant, table property. Reader version, writer version. These all are my table properties. So that's how you can actually see the table properties for your, you can say, tables, just tables. You cannot write like for delta data. Let's actually try, maybe they have added this feature, not sure, but I don't think so. There should be, but let's see, because I can expect this. And let's say for sync, show table properties. Yeah, it is there. Yeah, makes sense, because all the delta objects are also treated as tables. So you can also use table properties with this particular command in the latest version. So that is amazing. Perfect. So that's how you work with the table properties command. Okay, makes sense? Very good. Now it's time to talk about vacuum command. What is vacuum command? First of all, just a precaution, you should use vacuum command very, very carefully. Okay, let's talk about it. What is that? So if I open DML sync folder, because this is the most relevant example to explain vacuum command. So you know that we have so many Parquet files, right? So many, like not so many, but as compared to others, we have so many, right? So if I say, if I 15% battery, okay, I will just put on my charger, wait. So if I say, are all these files being used by my table? The answer is no. I said, like, let's say my table state is as 5th, right? We just saw that, and we have that current state of the table. So obviously some of the files are used for the fifth version of my table, right? The current version of my table, or you can say this particular delta data. Makes sense. Others are not being used for fifth current version. Maybe I deleted the data, maybe I updated the data. So those partitions are tombstoned, right? Those partitions are tombstoned. So those are not being referred by my table. So this is just fifth version. Let's say I made so many changes and I am currently now at 500th version. Obviously I do not need these partitions which were referred in the, let's say, version 1, 2 or 3. Obviously I do not need that. So in order to remove the Parquet files, we have to use vacuum command. Why? Because Delta Lake never removes your Parquet files, never. And we know the reason, because we can just go back in time using our, you can say, time traveling. But you know what? You can just go back in time for 30 days only by default. You can obviously change this particular information by setting the table properties at the Spark session level as well. But by default, transaction log keeps the log for 30 days only. So you can actually see all the information like which file to add, which file to delete, just for 30 days. That's it. Make sense? You can enable it, like when they say like 100 days, but by default 30 days is enough. Okay, because no one wants to go to the data which was inserted 3 months back. It doesn't make any sense, right? 30 days is fine, because in most of the scenarios you will say, hey, today, this morning, we received corrupted data. Let's move to the data that we received yesterday. That's it. At max 7 days. That makes sense. 30 days still makes sense, but after that doesn't make any sense. Doesn't make any sense. Okay, especially with big data. So now, because obviously you can just backfill your data, so why do you need to just keep all the files, right? So in that particular scenario, you have to use vacuum command. So what vacuum command will do, it will physically remove your files, but it will only remove those files which are older than 7 days, right? Older than 7 days, because obviously if you just remove all the files immediately, you cannot go back in time. So by default, Delta Lake is so possessive for us. So it keeps the retention period to 7 days for us, and it forces us, hey, do not delete data which are not older than 7 days, because you may need to go back in time, because it is so possessive for us. So by default it says this, right? But still in some scenarios we have to do this, so it is fine. We can do that. We can simply force Delta Lake as well to, hey, just remove it right now. Okay, so I will just show you how to run vacuum command. Okay, so it is very simple. You simply say vacuum and then delta dot your location, and in this particular scenario this is the location, DML sync. Okay, perfect. So it will simply remove my physical files, right? And if I want to just run this, obviously it will run this, but nothing will happen because neither of these files are older than 7 days. But if I want to force it, then I have to write something like this: retain 0 hours. So that's how you can say, hey, I do not want to retain any data, just say retain 0 hours. It will simply run it. But if you will run this, it will throw an error or a kind of warning, hey, are you sure you want to delete this data? So that's why I told you, just use this command cautious, like with precautions, and obviously under the senior supervision. Why? Because see, you are if you are just newly joined the organization, you do not want to just delete their data. Maybe like your manager will say, let's suppose the scenario, you use the vacuum command, okay, and you are very happy. I just used a new command on my delta table, and immediately your manager came to you and he said, hey, can you please, he or she, whatever, and the statement is like, can you please move your data to, let's say, 10 days back, because we have to check something. We have to check some logs and all, and whatever there was. And you were like, okay, how we can just do that? So do not do this. Okay, always use this command with precaution, and obviously knowledge is important. You should have knowledge about this command. But obviously whenever any interviewer asks you about vacuum command, answer like this. Like, obviously first of all tell about vacuum command, but always add this thing that we should not use this command without any confirmation or without any, you can say, senior user provisioning team, because this command is risky and we have to just take care of our data precautionally, because that way interviewer will think that guy or girl is responsible for the data. And let me just tell you, organizations are very possessive for their data. They cannot afford to lose their data. That's why you have to show that interest as well, like you are equally considering their data important for you as well. Okay, just a tip, just psychological tips. Okay, so it was all about vacuum command. Let me just see if I have anything to just tell you. Okay, let's talk about this command as well. It is very handy and it can save you a lot of time. It is called cloning. Let's say I want to create a table on top of this particular delta data, this one. So what I can do, I can use cloning in Delta Lake. And what is the advantage of cloning? It is very easy. So the thing is, let's say you have this table and we know that we have so many versions of the data or delta table, right? And this is the current version, which is 5th, in which we have ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I want to clone this data, that is for sure, that is easy. But I don't want to clone the exact data that is for now, that is like I'm seeing for now. I want to clone this data from version 3. So in that particular scenario, I can use cloning and I'll simply say create table delta lake Ansh dot default dot clone table. Okay, and then I will simply say clone delta dot this particular location. Okay, and then I'll simply say version as of, let's say 3. Let's run this. I will simply clone the data based on our, let's say, that particular version. Okay, and I will even show you. This is done. Let's try to query this our new table. And let's see what do we get in this table. And you know, with this just one command, you have your data ready in your tables. See, select asterisk from this table. And we should not see the current timestamp, like current version of the table. We should see the perfect, just 8 IDs, like 1, 2, 3, 4, 5, 6, 7, 8. And the older version of ID 1. That's how you can clone any table from any version as well. That is the power of, you can say, cloning in Delta Lake. We have 2 types of cloning, deep cloning and shallow cloning. This is called deep cloning, when you just clone the data as well along with the metadata. But when you write something called as shallow clone, like this, shallow clone, let's say clone table shallow. So if I just run this, what will happen? It will create a clone. Shallow clone is only supported for the manage table type. Okay, so manage, makes sense, manage. So shallow cloning is just available for manage table type. That is not a big deal. Let me just tell you what will happen in shallow cloning. What will happen in, you can say, when you want to shallow clone your data. Shallow cloning says, I will not clone the data. I will only clone the delta log, or basically the metadata of the files. Oh, so data will reside in the source table itself or source location itself. But we can definitely clone the table, but this command is only available with manage table. So you can simply say, hey, clone first table something, first table. So it should work. So it will simply create a shallow clone on this. Cannot be found. Oh yeah, we need to define delta lake dot default dot this. Perfect. So this is all about shallow. What's wrong with you, bro? What do you want? First table. Yeah, I just mentioned wrong delta or like catalog name. So this is all about your shallow cloning. Okay. So this way, it will not actually clone the data itself. It will just clone the metadata and all the information that is required to query the table. I personally do not like shallow cloning. I do not like it. I am the fan of deep cloning, which is this one, in which we also get the data as well, because it is independent of source. Let's say you are shallow cloning something and source person, or let's say source data owner, delete some records. Your data will be blocked, bro. So that's why I always go with deep cloning. But yeah, in some scenarios, we have to use shallow cloning. Let's say just a quick prototyping, just a quick POC, just a quick ad hoc, where you are not looking to maintain that data for the longer run, just for quick analysis. That is good. Okay. So this was all about table utility commands. Let me just confirm I have covered all the commands for you, bro. Okay, done. Yeah, all are done. So these were all, you can say, basic. Obviously, there can be like many commands, but these are the commands required for data engineering. Obviously, Delta Lake. So this is all about your table utility commands, and let's actually jump on something called as change data feed. I am the fan of change data feed. Why? Change data feed is like exceptionally good, and it, let me just give you a hint, it is related to change data capture in SQL servers, or you can say change tracking in SQL servers. Okay, let's talk about it. So let's talk about change data feed and why it is one of the most important things that is introduced in Delta Lake, and you will love this. So first of all, I recorded this video and I realized like my voice was not captured, so I am re-recording it, so don't worry about that. So basically, change data feed. Change data feed is similar to your change tracking, or you can say CDC, in your SQL tables. So let's say before we were only worrying about the incremental data, or you can say new data that we ingest. Okay, we were not actually worrying about the changes that we are making, but with the course of time, along with the new data, we were also worrying about, hey, what changes are we making in the source? So that's why we introduced something called as change data capture. That means if you are inserting any data, if you are updating any data, if you are deleting any data, we want all the information, row level changes. So that's where this concept CDC comes into the picture in the SQL world. Okay, and it's also called as change tracking. If you are familiar with MS SQL Server, okay, it is like lightweight CDC. So in the Delta Lake, it is called as change data feed. So basically what it does, change data feed allows Delta tables to track row level changes. That's the best thing. That means whatever we are doing within the rows, we are updating the rows, deleting the rows, updating the rows, we can track those changes with the help of change data feed. And the best thing, you can read the change events in batch queries using data frame APIs like df.read, the same way that we use in our, you can say, batch streaming or batch processing. And in the streaming as well, we can just use it with the df.read stream. So that is the best thing. Use cases, obviously silver and gold tables, especially gold tables. I will not say even silver tables. We do not need to, I think silver tables, yes, it can be. Yeah. So silver and gold tables. So improve delta performance by processing only row level changes following initial merge, update, delete operations. Because sometimes you need to simply travel the changed data only. You do not need to travel any, you can say, stale data or which data was not actually changed. So let's say you incrementally loaded the data. Okay, you incrementally loaded the data here, and this is like so much of data. But you realized when you just queried the table, the changed records are very less. Changed records are very less. So you can simply map this data with this one, and you can actually prune this data with this one, and you can simply say, hey, this is your change data. So this is like one of the use cases. You can just apply anything. You can also say audit trail table. You simply need to track the audits, like what actually happening with your table if you have a very critical table. Okay. Then this is the code example, and do not need to worry. Let me just take you to my notebook just to explain you everything. By the way, this notebook is created because I just recorded it and then I realized, oh, the sound was not on. But still, I will simply redo this part. So the thing is, first of all, in order to enable change data feed, we have to use this table properties, which is called delta.enable change data feed equals to true. Make sense? If you already have an existing table, you use this. If you have to just use a new table, then also you will use the same table properties. You will write something like this, create table, and after writing it, you will simply use table properties like this. Table properties, and then just use the same code, this one in the bracket. Okay. Then we enable this. Okay. Then we simply query the data. Simple, without any changes. So this was our table, which is clone table, and this is the current version of it without changes. Then I simply run this command, which is, you can say, insert into. I simply inserted one record. You can see 10, and this is the value. Then I updated the same record, which is 10. See, then I deleted one record, which is ID 3. Then I simply ran one command, which is describe history. And why? Because one key note, you can only track the CDF, or you can say row level changes, only after the version when you enabled CDF. Just use your common sense. If you have not enabled CDF till version 3, let's say for example, how you can just track the changes of version 2? Obviously no. So that is why I just showed you that we enabled CDF here in the version 1. So I can only track the changes after version 1, not before version 1. If we query version 0, it will throw an error. We have to say, give me all the changes after version 1. And these are all the changes. Now let's actually see the code, how we can just get the CDF. So the code is very simple. It is saying select asterisk from table changes, then table name, then the starting version, which is 1. You can even add the end version as well, but for now we can simply say, hey, give me all the changes. Okay, so this is the query. Let's run this and let's see what we get. So this is the data that we got. So first of all, you simply need to focus here, commit version. Okay, so this is the starting version, second, in which we inserted the data. Makes sense. Then we have 3 version, which is coming 2 times. Why? Because we updated the data here. But Delta Lake says, I will give you the flexibility to show you the pre-image of your data, which was like the image before update, and the post image of your data, which is after update. So it's up to you. Whatever data you want to use, you can use it. That's amazing. That's why you are seeing 2 times, and pre-image and post image. Then the last change that we made, which is deleting the record. That's how it gives you the changes in your, you can say, query. But if I query like this, let's say I want to query from 0. Can I do this? Can I? No. Because it is saying, hey, I cannot grab the changes of 0th version because CDF was not enabled for 0th version. It was enabled at version 1. So I will simply say 1. Do not cry, just give me 1. That's it. If you want to just set the end version as well, I can simply say version, let's say 2 or 3, something like that. Let's say just 3. So I will simply get the version from 1 till 3, not 4. So I will not see that delete record. See, only 1, that is insert, and pre-image, post-image. That's it. That's how your CDF works with Delta Lake, and it is an amazing feature. I personally like it a lot because we can simply apply so many use cases with this. It all depends upon the requirements, but it is really helpful. Makes sense? Now let's talk about something very revolutionary, and with this particular feature in Delta Lake, we can say that, okay, Delta Lake is the master of all the open table formats. Why? It is called uniform. Uniform means universal format. Okay, what is that? Let me just tell you what is that. So basically, let me just take you to the documentation page first of all. Universal format, let's try to understand it. It is very important. It is very important. Let's type universal format Delta Lake, and in short it is called uniform. Okay, so this is the uniform. What is uniform? Let's try to understand it. So uniform is very revolutionary. So in short, if I just want to define uniform in one line, this is the perfect definition. Delta universal format allows you to read Delta tables with iceberg and hoodie clients. Did you understand this? So let's say you are writing everything in Delta format. Yes. Okay. You are preparing your tables in a Delta format. You are writing your data in the Delta format. Everything is in the Delta. But let's say in your organization, you are also using iceberg and hoodie clients as well to query the data. Obviously, you would need Iceberg engine, Hoodie engine for that. Okay, what are like which are engines are compatible with that. So Delta table says you do not need to migrate your data. You do not need to just reread the data from the Delta format and then just push it into the universal, you can say Iceberg or Hoodie format. You do not need to create multiple copies of your data, because let's say in your organization you use Delta and Iceberg both. So you do not need to create one copy of Delta, one copy of Iceberg. So here comes the concept of uniform. So let's read what is written. Uniform takes advantage of fact that Delta Lake, Iceberg and Hoodie all consist of Parquet data files. That's true, because the original data is sitting in the Delta, Hoodie and Iceberg, like the real data is sitting in the Parquet format. Obviously, the only difference is with the metadata log, or you can say transaction log, or you can say the log folder that it creates. In Delta, it creates Delta log. In Iceberg, I don't know, whatever it creates. I think I think manifest files or and all. In Hoodie, I don't know, whatever it creates. So there's only change of the metadata log, right? So it says uniform automatically generates Iceberg metadata asynchronously. Like, what does it mean? So what it will do, it will simply write your data in the Parquet format. It will create one metadata folder of your Delta, one metadata folder of your Iceberg, one metadata folder of your Hoodie asynchronously. That means it will not wait for your Delta folder to complete, then it will create Hoodie, then it will create Iceberg. It will create in parallel, asynchronously. Make sense? So what is the advantage of it? So now your data is sitting here in the Parquet format. You have one Delta log, you have one Hoodie Delta log or Hoodie log, and you have one Iceberg log. You can use any engine to query the data. Wow, that's amazing. That's amazing. So that is the power of, you can say, Delta log, universal format, and that's amazing. Okay, makes sense. So you need some requirements, and obviously uniform, Iceberg, you need this version, reader version 2 and writer version 7. That is fine. Then this is in preview, but Iceberg is in, you can say, generally available, but Hoodie is in preview. And if we just want to enable it, we need to use these properties. If we want to enable Iceberg metadata, we need to use these properties. If we want to enable Hoodie, we need to use this. So let's actually try to see this with an example where we will just create a table with Iceberg Delta log enabled as well. Let's try to create that. And this is the way we create it. So we simply need to create a table. Okay. And here we can obviously create a table, and then we will simply create this Iceberg engine and this one as well. Okay. And in Delta 3.3 and above, you can enable or upgrade uniform Iceberg as well. If you just want to, let's say, upgrade your Iceberg compact v2 like this. So it is like recently added, like after 3.3, and after 3.3 we have directly 4.0. Okay. So this is an amazing feature, uniform, and I personally loved it. You can also enable Hoodie, but it is in preview, so I would recommend to just get started with Iceberg. Okay. Makes sense. Let's actually try this. I want to try this. So let's copy this code. Okay, and let's try it here. So let's create a new notebook. Let's say eight, and then oops, 8. So let's give the heading, and I will simply say uniform, universal. Oh, it's fine, uniform. Perfect. So let's actually try to just write this data here, and I will simply say create table, and we want to create table in our catalog. I will simply say Delta Lake Ansh dot uni table. Obviously, by first of all we need to say default, then uni table. Okay, and this is the, you can say, format we have to use. Okay, Iceberg. So let's try to create this table. So we are simply using the table properties which are given in the documentation, which is saying enable Iceberg compact v2 delta.universal format.enable formats, and that's it. So let's wait, and it will simply create a table. So what will happen? I will show you, don't worry. Syntactical error, create table using delta invalid syntax. Oh, it is running as Python. We need to run it as SQL. So our table is created, okay, and obviously it is a managed table. So I will simply say insert into, okay, insert into. By the way, we didn't define anything, so we do not have any kind of columns. But let's say I simply say insert into, and delta lake Ansh dot default dot unitable. So what will happen in this case if I just insert any data in real world as well? So it will simply store my data in the Parquet format, right? In the form of Parquet format. Okay. And it will create two folders. One is for delta log, second one is for iceberg. And let me just tell you the name of the folder as well, because I have already used it in my cloud accounts where we have like external tables as well, and you need external tables to see the folder names. But here it is like managed table, which is managed by Databricks. So actually you do not need to see that table. So yeah, so there will be like total 3 folders. One will be delta log, obviously, and one will be called as 1x. So there'll be 3 folders. Okay, this is the first folder in which we will be having our Parquet files, and it will be called as 1x. Okay, then there'll be a delta log. Makes sense? Delta log. Then there'll be one more folder which is called metadata. Metadata. So this metadata folder is for your, you can say, iceberg metadata files. So now this table can be used by your delta log, or you can say delta lake client and iceberg client as well. That is the power of your uniform table. Make sense? You can even go to the catalog just to see this table as uniform. Simply go on default and tables 5. Simply click on uni table, and you will see the maybe in the sample data or details. Yeah, perfect. So here you can see that universal format enabled iceberg. So that's how it maintains all the things. And delta uniform iceberg, see, it is saying that, hey, uniform format is enabled for iceberg, and metadata location is this one, S3 bucket. Where is this? It is managed by Databricks for your Databricks free edition. So obviously we cannot access it directly, but this is the location. This is the location, like S3, DB storage, and all these things. Make sense? So your data, you can say delta log version of iceberg is created at this particular location. Make sense? Make sense? And you can also see the folder name. It is called metadata. See, this is the folder name, and I already told you it is called metadata because I have already created that. And it has this particular JSON. It is called 000 metadata.json. This is the power of uniform. This is the power of uniform. I hope now you understood this concept uniform. And if it was critical, like obviously it is critical. If it was complex, now I don't think so. It is complex topic. It is very easy, right? So now let's see what do we have. So now let's talk about our next chapter, or I would say last chapter, chapter number 9. It is called optimization, because we have learned so many things in the world of Delta Lake. Now let's actually talk about those things which are actually in demand. Like obviously all these things are in demand, but I would say those are more in demand, or you can say you can expect more questions in the interviews related to this particular section. Okay, so what is this? I will say 9 Delta Lake, last chapter Delta Lake. It will be special, don't worry. So let me just attach this particular notebook. So we have some optimization techniques or optimization commands in Delta Lake. What are those commands? How we can just work with those commands? Let me just tell you. Basically, let's say you have a Delta folder. Okay. You have, let's say, 1 file, 2 file, 3 file, 4 file, 5 file, 6, so many files, right? So many files. Perfect. Now, our Delta Lake, or you can say all the big data frameworks, are designed in such a way that they should handle big data. But when we process our data frequently, obviously the size of file that we will get will not be that much big. Common sense, yeah, makes sense. So in that scenario, performance degrades, and this problem is called too many files, or you can say too many files or small file problem. These are two famous names. Okay, and I'm so sure exactly these terms can be used in the interviews as well. Too many files or small file problem. So we understood the problem, but what is the solution of it? You will say, bro, like we are ingesting the data, and if we want to process it frequently, obviously there will be like smaller files as compared to bigger files. That's where one first powerful command comes into the picture, and you are already familiar with it. Oh, it's called optimize. Okay, yes, you are already familiar with it because we have already seen this command, but now it's time to talk about how it does that. Basically, it is a rule of thumb that it is always easier to read lesser and bigger files as compared to smaller and too many files. This is the rule of thumb. Okay, now optimize command will coalesce. Coalesce means just merge, combine these too many small files into the optimal file, or you can say size of file, or it will just create lesser files of bigger data. Makes sense? Let's say we have 1 2 3 4 5 6 7 8 9. So these 9 files may be converted into two files, two big files like this. And who will decide the size of this particular, you can say, files? Obviously optimize command. Yes, we can make some changes, but by default it automatically picks the optimal size based on the, you can say, engine, based on the performance. And it can be like somewhere around 1 gig, like 1 GB. Okay, so if it is lesser than 1 GB, most probably it will simply create only one file. Okay, like one file, like let's say like this. So optimize command is actually optimizing your performance for your delta table. Make sense? Very good. Now let's see this command with the help of an example. Let's create a table. Let's say not create a table. Let's write the data to a destination. Okay, let's create a directory here in the default, in the volume. Let's create a directory called optimization. I will simply say optimization, and within the optimization I will simply say optimization file. Okay, perfect. Optimization. So what it will do, let's first of all try to push some data. Okay, and let's get the data frame if we have any. If we have any data frame, do we have any data frame here? No, we do not have any data frame, but not a big deal. We can simply create a data frame quickly, and let's say I will create a data frame. df equals spark dot read dot table, and let's create a data frame on top of delta lake Ansh dot default dot clone table. Okay, dot clone table. Let's actually create a data frame. Perfect. Let's say display df, and let me just show you the source data. So this is the source data, and we are simply creating a data frame on top of it because we want to write that data in this particular volume, which is called optimization. Let's actually try to write this data. Okay, let's say df dot write dot format is delta dot mode override dot save as table, not save as table, just dot save, and then simply pass this location. Perfect. Let's do this. I do not need to ask, hey, what will happen? Obviously it will create a delta. Let's say I want to rerun this command. Let's say my notebook is scheduled to run very frequently, and it is running in every, let's say 20 seconds, 30 seconds. Let's run this. Okay, let's run it for one more time. Perfect. So we just ran this particular notebook 3 times. Let's see how many files do we have. The answer is very simple, 3, right? But do you know what? These are small files. Makes sense because we do not have like much data. And let's say these files are being created in every 30 seconds, how many files we will be having in a day, how many. So we can simply run optimize command, and what you know what it will do? Optimize command will simply create only one file by coalescing all these three files, and it will simply say, hey, do not read these partitions, just read only this big partition. That's it. So let's actually see it with the example. I will simply say optimize table name, and I will simply say delta dot backticks, and perfect. Let's convert it into SQL cell. Let's run this cell. Now you will see another partition here. Let me just refresh. Default volumes, this, perfect. So we got another partition, fourth partition. Where is that fourth partition? So why are we seeing 3 files only? We should see 4, right? Why? Because there is no need to apply optimization here. Why? Because here is the glitch. We are using override command. So obviously, if we are using override command, it is simply overwriting the data. There is nothing to coalesce. Coalesce happen when you have like multiple files. Okay. So that is the thing. So what we can do, we can simply now say append. Okay. Now say append. So what will happen? It will create one more file and then go to default volumes optimization. We have 1, 2, 3, 4 files. Now let's run optimize for one more time. Let's see what happens. Okay, because I was checking like, hey, where is my optimization version? And I was not seeing it. Then I was like, bro, you are using override command. Now if you just run this, you should see that you have version with optimize command. See, version optimize command. Perfect. Now you have optimized this. Now we have 1, 2, 3, 4 files. Now if I refresh it, I should see 5 files. 5 files means coalesced version of all the files. Okay. So I will simply say default volumes, delta volume, optimization, 1, 2, 3, 4, 5. Perfect. So that's how you just apply optimize on top of your data. Make sense? Make sense? Make sense? Make sense? Very good. Now I know this is an amazing feature, and now you know the power of it. It improves the query performance as well, because engine just needs to read fewer files, and obviously it promotes readability and obviously query performance, everything. Now if I tell you we have a cherry on the cake here as well, how? We can boost the performance of optimization command itself with the help of another command. It's called Z order by, or it is also called as Z ordering. Now what is Z ordering? So let me just tell you. We know that if we have, let's say, small files, it will be converted into, let's say, 2 big files. This is just optimize command. But when we say Z ordering, do you know what it does? It simply co-locates the similar data, and it sorts the data between the partitions as well. Plus it calculates the column statistics as well. Column stats, simple. Column stats as well. Column statistics. Okay. Tongue twister. So it will just take care of column stats as well. What is the benefit of it? So let's say in this particular Parquet file, you have min value of ID 1 and max value is 10. This has min value 11, max value is 20. So if I query something like this, select asterisk from this table. So, and I'm saying where ID equals, let's say 5. So what will happen? Obviously, if we are not using column stats, it has to go to both the partitions just to check, hey, where do we have 5, right? But if we have enabled Z ordering, what it will do? It will go to the first partition. Obviously, it will see the column stats. It will say minimum ID is 1, maximum is 10. That means all the ID equals to 5 will be in this particular Parquet file, right? All the makes sense. Then it doesn't need to go to this particular Parquet file, or you can say partition, that is called data skipping. This is the concept of data skipping with the help of Z ordering. And yes, we have to use it with optimize command. Let me just show you the documentation page now. So if I just go here, optimizations, so this is data skipping. Let's read what is written here. Data skipping information is collected automatically when you write data into Delta Lake table. Delta Lake takes advantage of this information, minimum and maximum value for each column, and at every time to provide faster queries. You do not need to configure data skipping. Feature is activated whenever applicable. However, its effectiveness depends on the layout of your data. For best results, use Z ordering. Now let's read the Z ordering. Z ordering is a technique to co-locate related information of the same set of files. This co-locality is automatically used by Delta Lake in data skipping algorithm. This behavior dramatically reduces the amount of data that Delta Lake on Apache Spark needs to read. See, the Z order data, to Z order data, you specify the columns to order on in the Z order by clause. Simple. Let's say I want to Z order by data on ID column. I will simply say Z order by ID. That's it. And this is the complete syntax of it. Simple. If you just want to apply Z ordering on a subset of the column or subset of the data, but that is fine. So here I will just show you how I can just use Z order by here. I will simply say, first of all, let's try to query the data. Okay, without Z ordering. Let's see what we have got. Select asterisks from default, not default. And what is the, I think we have the Delta Lake, right? So we will simply say delta dot backticks, and this is the folder. Okay, perfect. Let's try to query this. And this should be fast enough. Why? Because we have enabled optimization technique, and this just took 3.7 runtime. By the way, this is not a decider because we cannot actually decide the performance using small files, but still you should see some difference. Now I will simply say optimize delta dot this table, and let's say, or basically let's try to query like this. Select asterisks from this where ID or cust ID equals 1. Okay. So it took 2.84 seconds. Okay. Now let's try to optimize it. Let's say Z order by, or I think we do not need to use space, or we need to use space. Let's check. Yeah, with space. Z order by customer ID column. I will simply say cust ID. So let's optimize this and use SQL. Perfect. Again, I'm repeating, the difference will be very minimal, but what is the issue? Optimize delta dot this. Okay. Z order by cust ID. What's wrong with this? Click on diagnose error. Due to incorrect use of single quotes or back. Oh, makes sense. We were using single quotes and backticks together. We need to use single tick here. Only one, like this. So let's see. This is applied. Okay. Let's again try to query the same thing. So the difference will be very minimal because it is already a small data, but you can see the max. Again, I repeated it, like it doesn't like give you a big difference. But yes, if you, let's say, dealing with big data, when you have like millions of records, you can see the difference in the time. Plus you can see the difference in the performance as well, not just like in queries and all. So that's how optimize and Z ordering go hand in hand. But now in 2025, we have a new command and it is game changing. It is called liquid clustering. Because for now, if you are not aware, data engineers were creating something called as partitions in the destination table. Partitions, not your like these partitions. Partitions means they were like actually organizing the data by dividing these files in the folders. Let's say they are making partitions on the year column, they are making partitions on the folder like month column, and all the, let's say, 2024 data will be in this folder. Let's say all the 2025 data will be in this folder. So they were just doing this particular practice till, you can say, 2025. Okay. But now it says, Delta Lake says, you do not need to create partitions. I will take care of partitions. I will take care of everything. So you just need to specify liquid clustering on your tables. That's it. Okay. That's why I didn't cover partitions in this particular course, because partitions are no longer required. Okay. Now what we do, we create liquid clusters. What are liquid clusters? So basically, instead of using partitions based on any column, we can simply say, hey, use liquid clustering or create liquid clusters based on that particular column. So what it will do, it will simply create clusters. Let's say one cluster is this, one cluster is this, one cluster is this. So it will create clusters obviously based on the values of that particular columns. And whenever we will be just trying to query the data, it can simply return the result much faster, and much faster means much faster as compared to partitions. Okay, plus these clusters are not like static clusters. These are evolving clusters. That means they will be changed and modified based on the query behavior as well. Let's say you are just trying to query some columns again and again. So it will be just evolving, and it will simply co-locate the similar data because it knows your behavior. It knows that you are just trying to query this data again and again. So let's combine it in one cluster. So that's how liquid clustering is actually changing the game. Let's read about it. This is the last topic of our course, and let's complete it. So if we have it here, all these things are covered. Okay. So you can simply check it, auto compaction, optimization, done. Let's see, where is liquid clustering? Where is liquid clustering? Okay, let's search. Liquid clustering Databricks, or you can search liquid clustering Delta Lake, same thing. Okay, liquid clustering Delta Lake. Perfect. Where is the documentation? Oh man, are you playing with me? Okay, let's see, refer this documentation, because this is just liquid clustering and we just want to know liquid clustering. Liquid clustering is like Delta Lake's topic, so do not feel like, hey, we are just opening Microsoft's documentation. It's fine. Okay, so this is liquid clustering. And what is liquid clustering used for? Databricks recommends liquid clustering for all new tables, which includes both streaming tables and blah blah blah. They're just doing marketing stuff. So let me just tell you, this is the thing. So we simply say create table, this, and just cluster by on this column. Okay, we can specify the column that, hey, just create clusters on top of this table. Before the previous upgrades, we were only able to create liquid clustering on new tables only. But now we can also alter the existing tables, and we can actually add clustering on those tables. I will just show you how. And the best thing, you have the liberty. Let's say you want to apply liquid clustering, but you do not know the best candidate for liquid clusters, okay, or column for liquid clustering. So basically, it is like being said, like we should always pick the columns for high cardinality, okay, where partitions cannot perform well. But even if you are not sure, you can simply say cluster by auto, and it will automatically pick your, you can say, cluster by columns. Let me just try to search cluster by auto if I can see anything. Cluster by auto. Okay, I got this. I am just looking for Delta Lake documentation. Let's see this one. This is Apache Sparks. Okay. So as you can see that we have cluster by command in Apache Spark as well now under the SQL reference. And let's try to, this is actually a new command, so maybe they're just trying to hide it. Okay, no worries. You can just keep this command in your mind. Okay, and I've already shown you the syntax. Let me just take you to my notebook. That is the best resource for you, bro. Do not need to mug up your mind. So I can simply say not create table. Let's alter the existing table. Alter table, and table name is Delta Lake Ansh default, and let's say clone table. Okay, I will simply say because we want to add a cluster. Okay, so we need to just say cluster by and then you can set a column. I think we have customer ID like this. Let's see if it works. Yes, so it worked. Now we have enabled cluster by on our existing table as well. So now whenever you will be querying this table, okay, we know like we just have like 8 records, but let's say you have millions of records. Now if you use this kind of predicate in your pruning conditions, in your where conditions, you will see the actual results and difference in results. Okay, plus you will say how many columns can we add. I think to my knowledge we can add 8 to 10 columns, and the best thing is you need to keep those columns in the first 32 columns of your data. Let's say in your Parquet file you have 50 plus columns. So just make sure whatever columns you're using in the cluster by command, you should keep it in the first 32 columns in that order. Why? Because by default Delta Lake captures the statistics of the first 32 columns. Okay, so just make sure that thing and everything is fine. If you are not sure about anything, just say cluster by auto and it is done. You can even run this cluster by auto. So this way you can actually create clusters on top of your existing table to improve the performance. This is all about Delta Lake course for you, and I tried my best to cover all the most important topics that are non-negotiable as per 2025, as per 2025 data engineering interviews, because everyone is talking about Delta Lake in the interviews and you need to know in order to ace the interviews. If you like this video, okay, if you genuinely felt that you gained a lot of knowledge, share this video with everyone, because this is a masterpiece and I strongly recommend everyone just to gain knowledge about Delta Lake, because Delta Lake is something that you need to know, and not everyone is talking about Delta Lake. I don't know why, but it's your responsibility to make this video available to everyone. Just share this video with your friends, with your peer data engineers, with everyone. Just try to help every single person who is like enthusiast and who is dedicated to perform better in the world of data engineering. Okay, so just drop a lovely comment on this video, and the best thing is I have attached an amazing video which is coming on your screen, and just click on this video. I will see you there. Let's complete this video as well together.